I'm super humbled that 50 people signed up for this thing, and not because I didn't think it would be a popular topic, but this is a Hadoop with Python is it's half baked. I'll be honest with you guys already, and I'm going to be honest with you guys about what works and what doesn't work, and we're going to talk about what's real and what's not. And what I mean by half baked is that Hadoop with Python. I've been coming up with this analogy where Python is almost like Hadoop's mistress, right? So Java is Hadoop's main thing, right? And it's native, and anything you can do with Hadoop that you're supposed to do, you can do in Java, right? So Python, it's kind of disconnected. So there's all these things on different random GitHub repositories that integrate Python with Hadoop, and all that. The issue is that doing Python on Hadoop is harder than doing Java from an operations standpoint. But as somebody that really likes Python and somebody that doesn't really care for Java very much, this is a topic that I'm interested in. So one of the things I'm going to say is that as 50 people that kind of agree with me, I guess, by spending a few hours of your day to talk to me about this thing, is that on some of these things that are half-baked, all this stuff is open source. So just by having you guys be involved here, I'm hoping that it turns into some sort of momentum that makes the Python plus Hadoop ecosystem a little bit more mature. And so that's kind of one thing I've been evangelizing lately. So that's kind of some of my ulterior motives here. Me personally, my name's Don, and I'm a consultant that does mostly Hadoop stuff. I do some data science stuff. And I've been working all kinds of different places and things. And a lot of times I use Python, a lot of times I don't. Does anybody have any questions about who I am or what we're doing here? Did you come to the wrong tutorial? Yeah. Yes. Yeah. So, sure, I'll talk about that right now. So what's coming around is a virtual machine that will be installed in VirtualBox. So if you don't have VirtualBox yet, Google for VirtualBox, and then download VirtualBox, install it, and then the virtual machine is basically an operating system. It's got Hadoop installed. It's got all the course materials and everything in it. And the way it works is that you import that thing. So you go to File, Import Appliance, and then you add the OVA file. And then you should see it in your VirtualBox window. And then, here, let me just show it to you guys. So after importing it, you should see Python Hadoop over here on the left. And then you just double click on it, and it'll start it. And then it'll start booting, and then eventually you get to a login screen, and then the password is Python. Okay? And then once you log in, you should see something like this with the desktop and all that good stuff. Okay? And we're going to be doing all of our exercises in here, but don't get too distracted by it yet if you have it up and running, because we're going to spend some time talking first. Okay? Does anybody have any questions about VMs? I'm not assuming that everybody has understanding what a VM is. Oh, there's 4 flash drives that are getting passed around. Who has not downloaded the thing yet? Okay, decent amount. All right, so I'm not too worried about that. We'll have about an hour of talking to do before we need to start up. So just keep passing it around. And also, please download it onto your machine and then pull the USB drive out and then keep handing it up, passing it down. Okay. Any other questions on the VM? So the VM is like a necessary evil because there's so many. I mean, it took me about, and I've installed Hadoop before several times. It took me maybe an order of like 4-ish hours to install everything that's on this VM. So since the tutorial is only 3 hours, I figured I'd fast forward that step. All right, because this is about Python, not about installing Hadoop. All right. So for the agenda today, we're going to do this introduction to Hadoop, which is going to take some time. So the way I designed this tutorial is I'm assuming that you have some sort of Python knowledge, and you know just about nothing about Hadoop. So I'm going to talk about what Hadoop is, why it exists, what it's used for. And then after that, we're going to get into MapReduce with Mrjob. And then we're going to do some exercises. And then I'm thinking we're going to take this break. So we have 90 minutes. So I'm going to try to get those 2 first bullet points done in the first 90 minutes. And then we have Pig, which is a Hadoop-specific programming language. And we're going to talk about using Python user-defined functions. We're going to talk very briefly about Snakebite. Snakebite, if we're kind of running short for time, that might be the first guy that falls off the bandwagon here, just due to its importance. And then we're going to just talk about HBase and Python clients, and we're going to talk about Spark and PySpark. The reason why I don't have Spark and PySpark stuff in this tutorial is because there's one tomorrow, I think. So I said, well, that guy just did my job for me, so I don't have to do that one anymore. All right. So we talked a little bit about the VM. Also, too, I'm going to ask you guys a general favor. There's 50 of you, okay? And I wish I could have brought like all my buddies to help me teach this class, but I would prefer if you can ask your neighbor first to see if they can help you solve your problem. And then if they can't solve it, if your other neighbor looks friendly, ask them too. And then you can ask me, okay? So chances are somebody near you has figured out maybe the problem that you have, and if not, then just at that point let me know, okay? Does that sound fair? I apologize. I wish I could be more interactive, but this is a big class. All right. So are there any questions on logistics or anything like that? Yeah. The slides are on the USB key. Oh, okay. Yeah. So the slides are on the USB key, and also they're in the VM as well. Yeah. All right. Any other questions? All right. Moving along. So what is Hadoop? So put simply, Hadoop is a distributed system for storage and compute, which is actually pretty important. There's distributed systems for just storage, and there's distributed systems for just compute, but Hadoop kind of met this balance of doing both at the same time. And that seems pretty obvious, but maybe you might be surprised. So if you think about 10 years ago, we had distributed storage systems. You've got like big box EMC storage, NetApp, to store tons of data. I had HPC and MPI, all kinds of scientific, like high performance computing stuff that did the compute stuff. But what Hadoop really did was merge these two things. And Hadoop itself is based on, so in the Hadoop world, Google is very much the voice of God, okay? So the way it works is that Google will publish out of the blue to some like mid-sized conference this totally obscure and vague paper, right? And then people start poring over it, and they realize the genius behind it, and then they go and try to re-implement it. And this has happened at least a dozen times. And Hadoop is one of these ones. So basically, the history of Hadoop here is that they published this paper on the Google file system, and everybody was kind of confused about why this thing existed. And we'll talk a little bit about HDFS. And HDFS from Hadoop is based on the Google file system, which was a paper published back about 10 years ago. And then MapReduce was based on a MapReduce paper that they wrote. But of course, Google only talks about it, right? They don't actually release any of their source code. So it's up to other people to implement it. So the Yahoo guys actually took it and re-implemented it, but made it open source. So that's the general history of Hadoop. And that kind of same pattern kind of bleeds through to a lot of different things in the Hadoop ecosystem. So I think the one downside is that it's built with Java. So built from Java from the ground up. And I was at a meetup group back in 2010. And one of the founders of Hadoop, this guy Doug Cutting, somebody asked them, why is Hadoop implemented in Java? Right? It seems like a bad idea. At least we should have done it in C so it would have been faster. Or maybe we should have done it in like even Python because then it would be easier to use. And he said, I implemented it in Java because that's the language I knew best. And it wouldn't have gotten done if it wasn't done in Java. So it was more of a culture call with how it worked at Yahoo and him personally. So it's not that it was necessarily a bad decision. I'm just trying to point out that it was relatively arbitrary. So, but today in 2015, there's plenty of options to be using Python with Hadoop, which is pretty exciting. So the first piece, so there's two major pieces to core Hadoop. And the first of them is HDFS. So HDFS is the Hadoop distributed file system. And really what it does is it stores files in folders. And it's really not much fancier than that. Okay? So from a user's perspective, you have a file. I'm going to store that file in Hadoop, in HDFS, and I can access that file. Right? Great. Simple. The access pattern is very simple. The other thing, too, is that nobody cares what's in your file. So it's just a steady stream of bytes. There's no sort of schema enforcement. There's nobody checking to make sure that your CSV is well formed. It's just, I'm writing a file to a file system. Okay. One big difference between HDFS and other distributed storage systems is that it chunks these large files into blocks. So 64 megabytes to 2 gigabytes is pretty standard. And when we're talking about blocks in a typical storage system, we're talking about in the order of maybe a couple K, right? Maybe even order bytes. But we're talking about a block size of 64 megabytes, 2 gigabytes. And this was how it was in the Google paper as well. And people were really confused when the Google paper was published because they were saying, well, this is really dumb, actually, from a storage perspective. So the reason why this is dumb from a storage perspective is if I want to access this 64 megabyte file block, I need to slurp that entire thing off disk sequentially. Okay? Like a typical distributed storage system is going to take this 64 megabyte block, split up into lots of pieces, and be able to pull them all down in parallel and bring it down a lot faster. So people are really confused. And I've actually asked some of the early Hadoop founders, because I was kind of in this boat too. Google published the Google file system paper before they published a MapReduce paper. And I remember on on websites and stuff where people were discussing Google file system, everyone was super confused about why they were doing this. Because this is awful storage. This is like one of the worst ideas for storage you could ever come up with. So it also has 3 replicas of each block. So every file that I write is copied 2 other times. So the storage guys are looking at this and like, man, these guys are clowns. So 3 replicas of each block, they had already solved with parity bits and striping the ability to store files at like maybe 80% efficiency. Meanwhile, this is like 30% efficiency, right? So again, kind of perplexing there. And then blocks are scattered all over the place, relatively randomly. So if I have a file that's 150 megabytes and I have 64 megabyte block size, that file is going to be split up into 3 blocks and it's going to split up over 3 nodes randomly. Then each of those has 2 replicas which are also split up randomly across the cluster. So it's also kind of seemingly disorganized. So for all intents and purposes, Hadoop distributed file system is bad storage. But it's really good at doing one thing, which is supporting all the other things that run on Hadoop, which now people are starting to realize, well, it's actually a pretty good idea. Okay? So kind of going to MapReduce. So MapReduce was the first execution paradigm that was built on top of HDFS. What we'll find later, when I'll talk about it a little bit more, is that when people say they're using Hadoop, it means they're using Hadoop as kind of a distributed operating system in a lot of senses. And at this point now, HDFS is the underpinning of that as the file storage, but now there's all kinds of things that are running on top of HDFS. So for example, MapReduce is slowly being replaced by Spark. You've got data storage systems like HBase and all kinds of things that are running on HDFS. So if I said what I think the core of Hadoop is it's HDFS, and then there's other things. But MapReduce was the first execution paradigm that ran on top of HDFS. And it, again, was a paper that was published by Google. And once the MapReduce paper got published, it was almost a year later after the GFS paper, everything made sense. Right? We finally had the complete vision. And the reason for that is that MapReduce, I'll explain what MapReduce does soon, but MapReduce likes sequential data slurping, right? So those large block files are very disk efficient from a hardware perspective when MapReduce starts running over it. And that's one of the big things. And also the replication helps dissipate hotspots on the cluster is another big thing. Replication is not only for fault tolerance, but it's also for performance. So there's all kinds of reasons why Hadoop or HDFS is perfect for MapReduce. but not perfect at other things, right? So MapReduce, which is what we'll be implementing some stuff in the Mrjob stuff that we're going to be doing, is a process that has 2 stages. So lo and behold, they're called map and reduce. And it's a framework in which you code a certain section of the framework, you plug it in, and then it handles all kinds of stuff for you. Okay? So the way MapReduce works is that you load data. Mappers are shared nothing. It looks at each record individually and doesn't care about the other records that are before it or after it. And it also doesn't care about what order you process records in. So if I have a long list of 1 billion records, if I write a function that processes 1 record, the MapReduce framework will take that one function that you wrote, whether it's in Java or as you'll be seeing in Python, distributes that across the cluster, and then runs it over your 1 billion records. Okay? And it creates some sort of output. So that's why it's called mapping, because you're taking the input and then you're outputting a number of records out of that. Okay? It's actually not that different from the map function or list comprehension in Python. So what it'll do is it'll load data from HDFS. You can filter data. So let's say of those 1 billion records, you're only looking for ones that have to do with Montreal. You can transform them. So maybe my date timestamps are in a format that I don't like. I can parse things. So I can maybe tokenize my strings. And then I'm going to output this key value pair from the map function. Okay? Now there's this big magical step in between the mappers and reducers that I'm not going to spend too much time talking about. But just believe me when I say that the framework's going to do a bunch of stuff, and then in the reducers, you're going to have a function in which takes in a key and a list of values. And so what you're going to write is you're going to write a function that takes in a key and a list of values, and you are guaranteed that when that function runs, it's going to run over all the keys that were generated from the map phase, along with all the values that had that key in that list. Okay? So it's almost like a group by operation. So in the mapper, let's say I output dog as my key, and then 17 is the value. Who knows what I'm doing? And then in another mapper somewhere else, I found dog, and I'm doing 18. Okay? And I find dog again, and I do 4. What happens in the reducer is I'm going to get dog as my key, and then 17, 18, and 4 as my values. Now, this seems incredibly simple, and you're probably thinking, like, well, what the hell can I do with that? You can actually do a whole ton of things, and actually I wrote a whole book on that called MapReduce Design Patterns. So this simple paradigm allows you to do summing, aggregations, it allows you to do filtering, it allows you to do joins between data sets. It's incredibly powerful, but it's almost like, I remember when I was first learning MapReduce, I've only gotten this feeling really twice in my life. Learning how MapReduce works and recursion. So, like, I remember with recursion when I was in, it was like an intro-level CS class. It was something that like finally just clicked. It's like, oh, well, I fully understand what this works. It was like all or nothing, right? MapReduce is very similar to that. So don't hurt yourself over not completely getting this paradigm. I think you'll be able to work yourself through the exercises, and maybe, hopefully, eventually you'll get it. The one thing I'll say too, just that reminds me about this class, is I don't know if this is what you were expecting, but I don't expect you to leave this class with anything like actionable. So what I'm trying to do here is I'm trying to provide you like the tip of the iceberg, right? I'm trying to give you a tour of the tip of the iceberg, and it kind of exercises to the reader to go figure out all the rest, right? Because what we're doing is we're covering a lot of different topics, and I want to give you guys a broad vision than going down one particular thread. So there was a tutorial on Mrjob, I think, last year. And they spent the whole time talking about this one tool. I'm trying to give you guys a good overview of Hadoop in general, and then Python plus Hadoop, okay? All right. Okay, so are there any questions about HDFS or MapReduce before I move on? You guys completely confused, or are you good to go? Good to go? I saw one thumbs up. That. All right.
Just poorly caffeinated.
Poorly caffeinated. Yeah, there wasn't any coffee around, was there? I think they will have coffee at the break, though, which is so just make it in for like another 75 minutes, and you're good to go. All right. Okay, so one thing is that when somebody says they're using Hadoop, it's almost like a lot of times somebody's saying they're using Linux. Okay? When somebody tells you that they're using Linux, it doesn't mean that they went to the Linux website and downloaded the kernel and are like looking at the code, right? What they mean by using Linux is that, I hope like Stallman's not here or something looking at me, but I think what people mean when they're using Linux is they have the operating system, and there's these kind of generally accepted tools that I'm probably using with that operating system, right? Like if maybe I'm using Postgres and I'm using Python, there's all these things that go into using Linux, and Hadoop's not that different. So when somebody's using Hadoop, it means that they're using Hadoop plus the grander ecosystem here. And what the grander ecosystem is higher level languages like Pig and Hive, and there's a whole slew of these more niche ones. There's HDFS data systems that provide more real-time access to data called HBase and Accumulo. There's alternative execution engines like Storm and Spark. So Storm is a stream processing system, and Spark is a batch processing system. It also does streaming, but it uses memory a lot smarter. And then there's also these things that are close friends, which really have nothing to do with Hadoop, but are used all the time with Hadoop, like Zookeeper, which does distributed syncing and locking. There's Flume, which does log collection and things like that. Avro, which is a data format that's being used a lot, and Kafka is like a distributed message broker. So these are some of the most popular things being used, but again, it's just all over the place. And every single, so I'm a consultant, I work with dozens of different clients. Every single personal Hadoop cluster is completely different. There's so much flexibility, and there's not very much standards in place. So everybody doing something is doing something different. They're using different things. Okay. All right. So the thing I'm going to go into now, something I like to do to kind of motivate you guys on why you should continue to listen, is I go through some of the cool things that I really like about Hadoop and why I think it actually has come to prominence, right? It's not, these things don't just randomly fall into place. Hadoop's really popular for some good reasons. And some of these are super obvious, but you may not realize how intuitive Google was when they figured some of these things out. So the first cool thing is linear scalability. So linear scalability means that, in general, I can scale different pieces of my cluster to get different things to scale with it. So for example, here are 3 examples. If I have twice as many computers in my cluster, then my job should run about twice as fast. And if I have twice as many computers, I can store about twice as much data. Okay? It also goes the other way. If I have twice as much data, but I have the same size cluster, my job should take about twice as long. Okay? And this is actually, I mean, I think as a computer scientist, I'm trained to not believe this, but it's actually pretty solid. So I've done proof of concepts on like 10 nodes, and said, well, we were running over a data set that was like 4 terabytes, and it takes us about an hour to process it. And they said, well, we want it to be about, we want it to run in less than 30 minutes, and we're going to multiply the data by 10x over the course of the year. So I tell them, well, you need a 200 node cluster, and then they go buy a 200 node cluster, and sure enough, it actually worked out pretty well. So, yeah. So the thing I have here, data locality here, and the main way that it implements linear scalability is data locality, which is something that was being done a little bit differently before Hadoop was around. So what data locality means is that when I run a process, it's moving the process to the data. Now this seems pretty obvious, right? So if I have a jar that has a MapReduce job, a Java jar that has a MapReduce job in it, I mean, that thing's on the order of like what? Even if it's bloated and shaded, it's like on the order of megabytes, right? Versus my data is like a petabyte. Like, why would I move the petabyte of data to the 1 megabyte jar? I should move the 1 megabyte jar to the data, right? Well, it's easier said than done, but that's basically what Hadoop did. And what that does is that it removes one of the largest bottlenecks, which is network I/O. So when I have processes that are running on the data, it gets slurped off disk, goes into the process, and then gets sent back down. There is network going on between that magic phase between the mappers and reducers and things, but for the most part, it's a lot more efficient than the opposite. So before my first Hadoop project, which was back in 2009, so my first Hadoop project was replacing this Oracle database. And the Oracle database had the compute in one set of nodes, and then it had like fiber channel or something like that to the storage. And you would run your query, and then it would slurp all the data out of the storage into the execution engine, run the query, and spit out. But it was all kinds of problems. And then when I heard this, I was like, well, that makes a lot more sense. But there's pros and cons. But data locality was the really big intuition that Google had that allowed them to scale to these tens of thousands of nodes, right? All right. So the next cool thing is schema on read. So I guess we're in Canada. I don't know how their politics are, but in the U.S., right? I'm kind of contrasting two things. I've got Congress, United States Congress, and I've got a cowboy. So what I would say is that relational databases and the old way of doing things are very much like the U.S. Congress, and Hadoop is more like being a cowboy. Okay. So what I mean by this is that with RDBMSs, everything has to be very well planned. You have to have your schemas in place. You have to design your ETL processes. Everything's perfect, right? And before you even write your first record into your RDBMS on any large project, like a government project or something like that, it may be like 6 months or a year before you even say, okay, we actually have our first record into the database, and you can query it now. And it's actually not that bad, because once you have the data loaded into your database, and the schemas are all perfect, and your ETL processes are all perfect, it's actually really useful, right? Like I can fire SQL queries around on this thing, and it's fast, and it's great. So I'm not really necessarily knocking this. I'm just pointing out the difference, okay? Well, maybe if I'm comparing it to the US Congress, I am. But so with Hadoop, what you do is you load data first, and then you ask questions later. So what I mean by that is that if you remember what I said about HDFS, it's just files, right? So I take my data, and I store my data in Hadoop. I get the data into the system, okay? And then all the processes that run over that data infer the schema at runtime, okay? So what this is called schema on write in standard terminology. This is called schema on write, and this is called schema on read. So what this means is I'm interpreting the nature of the data at runtime. And this is a really subtle but awesome difference, okay? It has some pretty interesting implications. First of all, I can keep my original data around. Like, why is this useful? Well, it's useful for a number of reasons. First of all, is that ETL process that the RDBMS guys built, and the schemas that they built, it's going to have bugs in it. And one of the problems is with RDBMSs in a lot of cases is that once the data gets ETL'd and written into the database, you throw all your old data away. Or maybe the applications are writing directly into the database, into the schemas, right? So one of the issues is that, well, that's annoying. So if I keep my original data around, then I never have to worry about that problem anymore. If there was a bug in my processing thing, I go update my MapReduce job, and then everything works again, right? This also has the nice thing of keeping the original data formats around. So I've ran into issues where, let's say there was an RDBMS that had been running over the course of 10 years. There's, like, every RDBMS project I ever worked on, you know the breakpoints of when something changed. So let's say, like, I was working on an RDBMS project back in 2009. Does anybody still need the, okay. You knew that, like, in 2004, they changed the data format, and, like, these columns are now different, right? Like, whenever they translated the data formats, not everything ever worked, or maybe, like, in the old data format, this column's always null or something like that. It was always a huge pain in the ass. So what Hadoop allows you to do is, well, I'm just going to leave the data in its original data format, and I'm going to leave it up to the programmer to consolidate these things. So you can kind of do things differently. Now, the downside of being a cowboy, right, is that it's a lot more work, right? So you have more power and you have more freedom, but at the same time, you have a little bit more responsibility, and you have a little bit more that's left up to you. So, well, what's the downside here is that, well, if I'm not competent and I don't know anything about my data, and I don't know to consolidate all these issues, then I can run into problems. Meanwhile, this kind of protected me from these things, right? Yeah.
The paradigm that I'm kind of seeing you say is that people have a lot of data in their databases, and then they want to do analytics. And a lot of the tools that people
Yeah.
So is it a common practice to have people writing directly to HDFS from an application? Or is it more common for applications to be writing this in a database,
Oh.
and take the database in order to HDFS?
Yeah. So the typical ingest path into Hadoop, how data gets into Hadoop, is typically the general issue with writing into a database and then writing database into Hadoop is that, well, actually, let me step back on HDFS. I think maybe I forgot to mention something. So one of the downsides of HDFS is you can't edit files, okay, which is a big limitation. But it almost forces you, what it forces you into is doing this append-only view of the world, right? So I only ever add data to my system. I don't change data. Okay, so in a keeping track of like a bank account, for example, the way I would do it in our RDDs is maybe I might update with transactions like the person's bank balance, things like that. In Hadoop, I can't really do that. Instead, what I do is I have to keep track of all the transactions. And then if I ever need to know that guy's balance, I need to run over all the data and calculate his balance. So, which is why Hadoop is bad at something like that, right? So the problem with writing into an RDBMS and then funneling that data to Hadoop is that if you're editing things in the RDBMS, it's really hard to keep track of the edits. If you're doing like an append-only view into the database, maybe it's not so hard, but still it's kind of strange. The typical ingest path is that the applications create files, and then those files then get written into Hadoop through some sort of intermediary. Some of the more modern approaches, there's like I've seen people use ZeroMQ or RabbitMQ or Kafka, which are these message brokers, where an application is writing to this message queue, and then there's a process that consumes the messages, and then writes a file to HDFS, for example. So that's a very loaded question. So hopefully I'm trying to confuse you a little bit so that you realize that this is actually really complicated. Yeah. Yeah. But I think one of the really cool things about Hadoop is that Hadoop it's not this or this, right? So what you can do inside of Hadoop is you can build this. And there's systems like Hive, Impala, Hawk. There's like SQL on Hadoop systems. We'll also be talking a little bit about Pig. So in a lot of senses, what I see the most functional Hadoop teams do is that they have the power to be cowboy when they need to be. But for maybe some of the users, they prepare that data in a way that looks more like this, right? So you can almost build like your traditional data warehouse inside of Hadoop in 2015 at least. Yeah. All right. The next cool thing is transparent parallelism. So one thing that's really awesome, and the reason why we could have this class, is that we have a VM that's getting passed around that we're going to do Hadoop stuff on, right? It's not distributed. Does anybody need the VM? We've got the USB keys or, okay. It's always interesting to see what corners get neglected. So anything that you write on your laptop today with Mrjob or Pig or whatever, you have the reasonable expectation that that will run over any number of nodes as long as Hadoop as an infrastructure can handle it. So if you write a Pig job or a Mrjob job here, then you should be able to go deploy that on like a 100-node EMR cluster tonight and not have to change the code. And that's what I mean by transparent parallelism. And there's all kinds of weird stuff that you have to worry about when you're thinking about parallelism. Do I have to think about threading and RPC calls, inter-process communication, locking, fault tolerance is a big one, scalability, right? Do my algorithms have to change when I get to a certain node count? So this is a big deal. Like, this allows you to develop an application on your laptop, which is the typical workflow when you're working with Hadoop is you're developing something locally, then you deploy it to the cluster, and then you don't have to make very many changes, which is really cool. The other thing, too, is that your code can change over time with the cluster as well. So if the cluster ever gets upgrading and you add more nodes, you don't have to go rewrite your jobs. You don't have to go update these like hard-coded node counts that maybe you would have had in there otherwise. It just automatically handles everything. So this is a pretty big deal. But the downside is that you kind of have to fit it into the Hadoop box. And what I mean by that is that You have to play by Hadoop's rules, and if you play by its rules, then it'll do transparent parallelism for you. If you try to think, you know what, Hadoop, I'm not following your rules, I'm just going to do my own thing, then things start breaking. Okay? Yeah.
That's sort of a deferred responsibility that, I mean, you can't, somebody has to know how many nodes are on the cluster. The fact that you don't doesn't mitigate that.
Sure. That's a great point. So it's not that you can be completely oblivious to how many nodes are in your cluster. What I mean is that the analytics developers that are writing the code that analyzes data can be oblivious to that fact. Which is, so you have the separation of operations and development, I guess. That's nice.
So there's no job management, like if you're the analytics developer and some person hands you a key to a 1,000-node cluster, you get it all, you screw
Yep.
everybody else temporarily.
Yep.
Then something else. So there's no job management.
There's the way the architecture is set up is that there's a master controller that you submit jobs to. That's a program, right? And then that program has some scheduling and some prioritization and things like that. But you can most definitely screw the other people in the cluster. So you have to be there are things you have to be careful about when you have a multi-tenant system, for sure.
But that's not you, the analytics developer. That's you, the
Yes, that's the operations guy, right?
the guy who's writing shotgun.
Yes.
To make sure it all
Yes.
works correctly for the
Yes.
for the developers.
Yes, I think some of the best ran Hadoop clusters have like I call them groundskeepers.
Yeah.
So the Hadoop cluster, the really big production ones, once you get to a certain size, you have like probably one guy that's keeping watch over everything. He calls people out when they're doing something dumb on the cluster. You know, he cleans things up over time, right? And he keeps the system healthy, right? Because the problem is that when you submit a job and you have 1,000 nodes, Hadoop is going to contribute those 1,000 nodes to that one person. It's not like a cloud infrastructure where I'm a user and I have an analytics. It's like, oh, you know what? I'll dedicate 3 nodes to you or something like that. It's like it gives the whole force of the cluster to every single request. Yeah. Yeah. So the one thing I want to point out, for example, here's a Mrjob word count example. Pretty simple. So this counts words, which is the canonical Hadoop example. So it basically says, you know, I saw the word dog 18 times. I saw the word Elizabeth 3 times in this document. If you look at this code, and I've cut out some of the boilerplate, but there's nothing in here about node count, parallelism, fault tolerance, right? There's nowhere in here saying like, oh, if this thing failed, restart it, right? All that is handled by the framework, which is really nice because it's separating my data analysis from all the things you need to be worrying about when you're doing distributed computing. I think what Hadoop did, the reason why it's popular, is that it struck the right level of abstraction, right? So it's high enough abstracted that you don't have to be worrying about like fault tolerance, but it's low enough still that you can still orchestrate the thing in the cluster in a way that doesn't blow everything up, and it's not super naive. So the next cool thing is unstructured data. And this one's kind of tacked on, but I wanted to add it. Because unstructured data doesn't really have to do with Hadoop, but Hadoop can definitely do unstructured data. So what unstructured data is data that doesn't have structure. All data has a little bit of structure, but what we generally mean here is that it's things like media, like an image file or a video. It's things like raw text, like human-generated text. Log data is another big one. Forms. So, I mean, like I filled out. I don't know. You see the world in such a different way once you've done a bunch of unstructured data analysis. So I filled out this like form. I'm sure a lot of you did if you came from the U.S. This form to get into Canada. It had like my name on it, and I had to write like what airplane I came in on and things like that. And I realized when I was writing it, like it said what country I was from, and I said, well, I guess I could. It's either like U.S. or USA or United States. I wasn't sure which one I wanted to write. I ended up spelling out United States, but then I realized there wasn't enough room, so it ended up being United State. And then there was something like the airline I came in on, and I said, you know, UA, it was like 1403 or something like that. I was like, oh, you know what? I should put the space or not put the space. Like, and then I realized, why am I worrying about this? It's the poor schmuck that has to read these files into their database, right? So obviously, I don't think I feel a little bit safer because I don't think they're mining those things for any sort of useful information. But I guess what I'm saying here is that kind of as a corollary to the schema on read thing that we had going on, anybody else need the VM? Good? All right, nice. Good job, guys. As a corollary to the schema on read thing, I can do pretty much anything that Java can do, and in some cases Python, to process this data. So if I have a Java program that analyzes a video or a Java program that analyzes an image or log files, I can do that. And there's a lot of these data formats that were really kind of annoying in RDVMSs. And these things have really helped out a lot. All right. Are there any questions on why Hadoop is cool before I move on to the next section? Is anybody still a doubter here? All right. Yeah.
You glossed over the app developer perspective.
Yeah.
He makes his little three-phase app, but he's also got to get his 47 petabytes of data in the right place.
Yep.
Which looks like it's a big problem relative to those three little snippets.
Yeah, so getting 47 petabytes into a cluster is something that takes a long time. And what that usually, if somebody says they have a 47 petabyte data set, probably means they've been running for a long time. So this is data that's been, if somebody said, I have 47 petabytes of data I want to analyze with Hadoop, well, let's figure out how we're going to get the data, and that's a huge problem. I've heard of people, there's actually services now that you can like load hard drives and then like actually ship them. Like, and actually you can send them to Amazon. You can send like a box of hard drives and they'll load them up for you and things like that. Because that's actually much more bandwidth than the internet can give you. Yep, exactly. It's some things never change. So getting data into the cluster most definitely is its own engineering problem. So like the analytics developers may be in a large enough team will be completely devoid of the guys that are sitting there getting the data into the cluster. So that's its own entire problem. Implementing data flows, it's a big aspect of Hadoop. And then the application developer, again, is kind of separated from that. Maybe he knows a little bit about what data is on the cluster. It's been curated. Maybe it's been documented. And then he can kind of run his analytics over it. Like, for example, I'm working with a client right now that it's building this thing that they want to converge all their data sources into this one Hadoop cluster. And the idea is that the selling point is that, hey, we've got all this data. They're a retail company. And they're saying, well, we have all the retail data from our POS devices and our e-commerce and things like that. But they have all these other divisions that have data that haven't been sharing with the rest of the organization. Their price of entry into the cluster is adding their data. So they have to like implement the data flows that funnel the data from their systems into the Hadoop cluster, and then they can analyze their data with the Hadoop cluster and also other people's data as well. So anyways, it's a really tricky question. There's not a good answer to it. Sorry. Any other questions about why Hadoop is cool? All right. Moving along. So why I'm excited about Python and Hadoop. So the first off is Python and Java. So if you take all the reasons why I like Python better than Java, they kind of all apply here, right? I've been a Python programmer since, I think it was 2000, it's like 2001 was probably when I wrote my first Python script. And it's always kind of been the language that I've known the longest and been kind of my favorite, and I've been kind of growing up with it. And I learned Java in college, and I'm a pretty proficient Java programmer. And then I got into Hadoop around 2009, and I pretty much only had to write Java at that point, right? And it's almost like I left Python behind. I'd have to do small projects at home to keep sane. But now that it's kind of converging, and also too, the other big thing that had changed, I made this observation. almost all the PyCon tutorials, like the majority of them, are data analysis related. I don't know if you guys noticed that. If you go look at the tutorial list from maybe a few years ago, it's not like that. It had a lot to do with like web frameworks and just frameworks in general, tools and things like that. Now, like, there's tutorials on machine learning. There's multiple machine learning. There's one on PySpark. There's pandas. I mean, there's even like there's some tutorials that even look identical. Like, I think they might be talking about the same thing. So what this is allowing me to do is that, well, Python is becoming very quickly this de facto standard of data analysis. And Hadoop is about data analysis, so it should make sense that these things are together. So the couple of things that I like about Python, just as a language, is a lot less boilerplate, it's easier to write, it's more expressive. And some of the things in particular, the first one is compiled for scripts. And this one's very, very subtle, but very important to me. So when I have a Java MapReduce job, let's use MapReduce as an example, I write my Java MapReduce job, and then I compile it. And then I ship it to my cluster. Okay? Now, I worked on this project once in 2011. And we had a board where we would tally every time we had a Java class path issue. So every time you had a Java class path issue, you'd go up to the board and you'd strike it. With a team of 5 guys, we had on average about 6 or 7 a day. Okay? And what this means is that, like, compiling Java and getting all the things into the jar that I need and then shipping it to the cluster, there's all kinds of things that can go wrong. So I can have things locally, that's a problem. I compile it and then I ship it to the cluster. Maybe my versions are different. You know, oh, well, I'm using OpenNLP version this and the cluster using this, and like, oh, well, I'll just shade my jar and it's a nightmare. And the reason why it's a nightmare is not because compiling Java is a nightmare, which I think it is. It's more the fact that I'm compiling Java on one platform and then deploying it to another. Okay. So actually, some people have even implemented like Jenkins on the cluster to make sure that things are getting compiled in the cluster's native environment. And I mean, you're talking about like a whole engineering effort just so that I can compile things, right? The other thing that's different about compiling versus scripts is, let's say I have a job that's running on my cluster and something very bad happens and I need to fix it really quickly, right? It's like, okay, well, let me go download the SVN repo and load up Eclipse, and oh, I'm gonna import all my jars. I mean, it's probably like 2 hours before you're even actually writing code. If I'm dealing with a script, and this is just in general of compiled versus scripts, is I'm just gonna SSH into the cluster, I'm gonna open VI, and I'm gonna change the script. And it's gonna be fixed within 30 seconds. Maybe that's not the best software engineering practice. You know, maybe I need to test that a little bit, but when the thing doesn't work, nobody really cares, right? So I've had to directly SSH into the systems and VI the script itself, and not being able to do that to me is like really scary. So that's one reason why I really like Python over Hadoop or Java. The other thing too is the Python library. Yeah.
So don't you have a similar problem distributing the Python versions, dependencies on libraries, etc.?
Yeah, but I don't think it's as bad. I think, like, so in terms of installing Python, you want to have all the libraries that you're using installed on all the nodes, for example. So if you're doing it right, maybe you're using like Puppet perhaps to install the Python libraries and things. But otherwise, you can just like SSH into every box and then do pip install on the 10 packages you want to use. It's typically what I do on kind of smaller range clusters. So, but
Do you typically have them run virtual environments?
no, not,
You see different developers having a requirement setting.
Oh, I see.
Python 3 versus 2.7 versus
Oh, I see what you're saying. So there's this. So one of the things you can do, and this is true with Python as well in here, is that a lot of times you ship the dependencies with your jobs. So there's nothing, and this is true with the Java stuff as well. So for example, if I'm using OpenNLP to analyze NLP data in my Java stuff, I'm not expecting that OpenNLP is installed on all the nodes that are in the class path. What I do is I incorporate that into my MapReduce job, and then I ship that, right? And the same thing is true with Python. If there's specific libraries that everybody's using, it probably makes sense to install them on the cluster. But otherwise, you can kind of package them up together and there's mechanisms for shipping all these things together. So that is definitely something you have to be worried about with Python too, but I think it's easier. I don't know, in my opinion. I probably know some Java guys that would disagree with me. So one thing that's really cool about Python, which I think if you're very narrow-minded in Python and you don't look at very much else, maybe you don't realize this, but there's a number of Python libraries that are like best in class. So, and what I mean by that is that I know guys that use like NLTK and scikit-learn, for example, and even scikit-learn, and don't really care about Python, but they know that scikit-learn is like the best at doing X. They know that NLTK is the best at doing Y, right? So I want to be able to use those really cool data analysis libraries with my Hadoop jobs. Like, what's so wrong with that? Right. The other thing too is integration with other things. So I mean, Java has great integration with lots of things, but I think Python is maybe rivals it. I'm trying to be a little careful with this argument because, I don't want to get shot. But all right. Are there any other questions why Python may or may not be a good fit here? So there's some bad things to this side, okay? So why not Python versus Java? So there are some things that Java's better at, and particularly like having compiled code is not always the worst thing in the world, right? I found that, for example, working on large teams, I personally think that Java might be better, just because of different safety mechanisms that are put in place. The one big thing is, with Hadoop in particular, is that almost nothing is native. So what that means is that everything you're writing in Python, for the most part, is getting translated into some sort of Java thing, right? Or it's running through a shell and then having data stream through standard in, standard out. So the one big hit you're taking is performance. And it's not performance like, oh, Python's slower than Java, right? There's that argument, right? Which I'm not talking about that. What I'm talking about is the fact that Java is speaking to Java. Meanwhile, Python has to be translated to Java through some sort of pipe or Jython or something like that into Java, right? So the fact that it's not native, it's almost like there needs to be something that's translated. Okay. The other thing too is being out of date. So a lot of these Python projects, for example, are just random dudes on GitHub, right? And they have jobs and things, and they're not really looking to update their projects every time Hadoop gets updated. So sometimes you run into issues where, actually, I ran into an issue with Mrjob where they changed the way that mkdir works, like making directories in Hadoop, and Mrjob started failing. And all I had to do was add like a one flag to a command. So I had to go like actually edit. In your VM, you actually have edited Mrjob so that it actually works in Hadoop 2.6. So that's one thing that you may have to do. Like, oh, I want to use this Python package. You may have to go like edit some source code. Being weird. I totally forget what I meant by that. Anyways, the other thing too is it's a much smaller community. So if you go to a mailing list and say, hey, I'm having this trouble and I'm writing it in Python, the number of people that are able to help you is much smaller than if you have a Java issue. So if that's really important to you, then that might be hard. The individual projects, like the reason why I picked Mrjob is it has one of the strongest communities in my opinion. So that's pretty cool. So I think you can still get help. The other thing too is that there are some big Hadoop vendors. So there's Cloudera Hadoop, Hortonworks Hadoop, MapR Hadoop, Pivotal, that do Hadoop support. I don't think any of them do Python support. I'm not sure. I'd have to ask. But like if you have an official vendor license of Hadoop and you can get support through them, like they may not be willing to help you with your Python stuff. All right. Are there any questions about Hadoop before I move on to Mrjob? Yeah. Yeah, it's all over the place. There is no binding. So the kind of question was, What's the binding thing that's pulling all this Python stuff together? It's really not there. And this is also kind of what I meant by my ulterior motive here with this class, is that I think there's a lot of maturity in terms of bringing the Python stuff together. And I think until the community gets more momentum, it's going to take some time before these things are easily accessible. Like all these things that I'm teaching you guys today in class are things that I've kind of seen or heard about, and I had to go individually download all these things and bring them all together. So yeah, it's a little rough. And also too, then you have issues with different libraries, Python libraries do things in maybe different ways. They are using different interfaces, things like that. So I think that's one of the downsides of doing this. Yeah. Any other questions about Hadoop? Maybe at this point I've convinced you to just use Java with Hadoop. I don't know. I think it's worth it. I think it's worth it. But it's not free, right? It's worth it, but it's not free. All right. Any other questions? Yeah. It's a great question. So what flavor of Linux do you want to pick when you're using Hadoop? It does not generally matter, but it depends on what installation path you want to take. So the installation path I took here was manually downloading all the different projects, bringing them into the VM, and then just starting them up, right, installing them. So I didn't use any RPMs, and I didn't use any sort of prepackaged things, right? I didn't use Yum or anything like that. So the way that I installed the system here, it really doesn't matter what Linux operating system you're using. The one big difference that you're going to flip to is if you, so probably the best, in my opinion, the best way to install Hadoop is to go to a vendor like Cloudera or Hortonworks and download their stuff and then install it. But as a consultant, I have to be careful about my allegiances, so I didn't want to like install Hortonworks and then be like, oh, that guy's a Hortonworks bigot, you know, like. So I unfortunately had to pick something neutral. But so if you go to like Hortonworks or Cloudera, for example, and you just download their distributions, they're all RPM based, and I believe due to the like changes in there are some pretty like big changes in how things worked in RHEL 7 and by proxy CentOS. So I think they're still recommending RHEL 6 and CentOS 6. And they've also just basically decided to do everything in RPM, so kind of Debian-based distributions are out if you want to use RPMs. On my personal box, I run, I'm using Mint, and I just install everything personally. So I guess what I'm saying is if you want to use RPMs, you have to use CentOS 6. Otherwise, you can do whatever you want. Okay. Any other questions? Yeah. All right. Okay, so yeah.
We had a class at the company in Cloudera a couple of years ago, and they talked about using Python and
Yep.
but they said that you lose a lot of the parallelism, and it ends up streaming and being much more single-threaded than if you do it as Java. Depending on what, and it depends on what stack you're using, whether you get the full parallelism of Python.
I have no idea what that person's talking about. Because so the things I'm showing you today, for example, Mrjob is writing fully parallelized like Python scripts. Pig is doing everything parallel. Yeah, everything we're doing today is like fully parallelized. There's no bottleneck that has to do with Python. Yeah, like we're doing it in Python. Like, so for example, the way Mrjob works, which I'll be talking about in a second, is that it writes the you write this Python script, and then the way it gets it into Hadoop is it uses this underlying. It uses a thing called Hadoop streaming, which allows you to write arbitrary programs that then pass data in and out through standard out. So effectively, what it does is it wraps your Python script, pipes the standard in the data, takes the output of your Python script to standard out, and then passes it through the streaming interface called Hadoop streaming. So that's providing full-blown MapReduce parallelism. The problem there is that now you're using standard in, standard out as your communication mechanism, I guess, and that's a lot slower than just passing something in through the JVM, right? So it's definitely slower in the sense that, but that's because of translation, not because of lack of parallelism. Yeah, so I really don't know what they're talking about, sorry. Yeah.
Curiosity, how does it take advantage of all the cores?
Oh, so the way that it takes advantage of all the cores, and this is true in the Java side as well, is that so a job is split up into tasks. A MapReduce job is split up into tasks. So each task maps to generally one block in HDFS. So if I have 1 million blocks, you can kind of expect 1 million tasks to spawn up. And let's say I have 100 nodes, or 1,000 nodes, let's say, to make the math easy. What you'll do is you have a number of slots per node. And the general rule of thumb is 1 slot per core. So if I have an 18-core box, I'll put 18 slots on the thing, and it'll spawn up a different JVM for each one. So in a Java MapReduce job, so they're not using threads or anything like that inside of the JVM. They're using separate JVMs for each task. And that has a lot of benefits from fault tolerance perspective and processing perspective. So when you're running, for example, Mrjob, which we're going to talk about in a second, what happens is that Mrjob, the underlying Hadoop streaming thing spins up a JVM, which then calls your Python scripts, in a subshell outside of the JVM, runs it through the Python script, and then pulls it back into the JVM through standard out. And so when you have 18 JVMs running on a box, because you have 18 slots, you have 18 Python scripts that start up that are funneling through standard in and standard out. So that's how they typically use all the cores. Yeah. There's no like GIL issue here. Yeah. Yes, we will go over them, and you will probably be very scared. All right. Let's go through Mrjob here real quick. So we've got 30 minutes until break, so let's try to get this done in 30 minutes. So Mrjob, so I originally called it Mrjob, and then I heard somebody call it Mrjob, and I just thought that was really cool. So I continue to call it Mrjob, as in, MR is Mr., right? So you write MapReduce jobs in Python, which is pretty cool. It's open source, maintained on GitHub, and it's maintained by Yelp, which is Yelp is almost like one of the champions of Python on Hadoop. They do a ton of Python on Hadoop stuff, which is pretty cool. So I follow them quite a bit. And like I said, it wraps Hadoop streaming, and then it uses Python 2. So there's no Python 3 support yet. Mrjob is very well documented. When I was learning it, it was really easy to get started. And one of the cool things that it has is it has really good integration with Amazon EMR. Amazon EMR is a MapReduce as a service platform that they have. So you can write a Mrjob thing, and it automatically spins up like an EMR cluster and runs it for you. Or you can run it also locally and on Hadoop. In the VM today, we'll be running it locally. So we won't actually even be interacting with Hadoop. It's more of a simulated environment, which is pretty cool. So let's take a look at the canonical word count example. So canonical word count, what word count is counting words. So I have text, and I want to count how many times I saw each word. Maybe that's useful for me for some reason, but it's a good demonstration of how Hadoop works. So what I have here is a script, and I'm going to kind of step through it step by step. At the top, I have this import statement where I do some imports. I have this regular expression that I'm going to use to pick out words. And then what I have is this class here that inherits from Mrjob. This is the thing I imported up there, which gives it a lot of the functionality. And then what I do is I override some of the functions in here. So this first one is the mapper function. And if you remember correctly, this mapper function is going to take in a line, and it's going to output key value pairs. Okay, so that's what this guy is doing. So the signature of this function is called mapper, and then self because we're inside of a class. And then I have underscore here because I'm showing that I don't need that. The first thing inside of the mapper function is the position in the file. So this is the byte position of where that line started. For word count, that's not useful. Okay, I don't care. So I'm just going to put underscore there, and I'm going to forget about it. And then line is the actual text that I have. Okay, so this is like a line of text separated by a new line in this case. Okay, that's configurable, but by default it's a new line, which is okay here. So what we have here is then I'm going to iterate. So I have a for loop that's going to iterate through all the words, and I'm going to use the regular expression stuff to pull out each word into a generator. And then I'm going to iterate through each of those things. And then I'm going to output the word. I'm going to lowercase it because the first letter in sentences are capitalized, so we want to make sure that those things match. So we're going to lowercase it, and then we're going to have a 1. Okay? And we're going to use a yield statement here, not return. Okay. So for those of you that don't know what yield is, I always have a hard time explaining yield, but yield is almost like return, but it's only returning one element in a list. So I can have multiple yields. So if you look at this function, I'm yielding this thing multiple times, every time for this for loop, but it keeps going, right? And then when this loop ends, yield gets this message to say, hey, the thing's over, right? So the reason why it's using yield here is because we're kind of returning multiple key value pairs per line. Okay. So if you look at what we're doing here, you have the quick brown fox jumps over the lazy dog. The way what it ends up yielding is for each word in order, it outputs the word and then 1. And what this kind of means is that, hey, I saw this word once. Okay. So then in the reducer, I get the key, or I'm sorry. So let's do another example. We just have, I like this Hadoop thing, and then it comes out again. So if you can imagine, let's say this line was processed on node 37, this line was processed on node 99, right? It's all doing the same thing. It's the same function, but different lines of text. Okay. Now what the reducer gets is it gets itself. It gets self here because we're in a class, and then we have we have the key and the values. So this thing is a single value, and this is actually a generator. It's a list of values. So what we get here is that dog, for example, comes in, and so the framework will be calling this function. It'll call it, and it'll pass in dog here, and it'll pass in the generator that has the list of all the items that had that key. So here, so what we're going to do is we're going to yield, because we want to do word count, we're going to yield the word, which in this case is dog, and we're going to sum up the values. So if you remember, all the values from the mapper were 1s. So when we sum up all the 1s, right, we get the count of the words of that word. And then this function will get called again. We'll get called again for cat, which has its own set of 1s, and then it's going to output cat 8. Are there any questions? Nope. Nope. The framework. So this is the only code you have to write. So the MapReduce framework, and this is basically what Java does for you too, is it's taking this key and this value that you outputted from here, and then in between this one space of white space, there's a whole ton of magic that goes on here, like maybe 100,000 lines of Java code, right? And then it goes to here, which then the framework is calling these functions. You don't call these functions, right? Effectively, so how I run this thing down here, I just do this .run. What this does is it takes this script and ships it all over the cluster, and then it knows to call the mapper function for each line, and then it calls the reducer function for the reduce side on the output of this thing. But it's not only the output of this one; it's the output of all of them, all of the ones that ran over all in the entire cluster, right? Yeah. Yeah.
So for some other function, it has
Yep.
selected would,
Yep. Yep.
some other hash.
Yep. Like if you wanted to do like this word is in this position in the sentence, for example, like you could instead output the sentence position, right? Or for example, in one of the examples we're going to be doing today, in the exercise, we're going to be doing the median salary based on your years of seniority. So I have some salary data from Baltimore City. So what you do is the key is the years of seniority, and the value is their salary, right? And then down here, what you're going to do is you're going to have the list of salaries, and you can calculate the median from that list. Yeah. So again, it's very very powerful in this.
It's just a coincidence in this particular case that you would just use the length that counts.
Okay, so you're a little bit too smart for me, because I didn't want to spend time talking about this, but I'll let you know, the secret. So there's an optimization here called a combiner that runs a mini reduce at the end of the map. And so what this means, and the reason for that is that, let's say I saw the word dog 18 times in one document. Yeah, the is a good example, right? It takes a lot less bytes to transfer over the, 1 8 times versus the, 8, right? So what the combiner does is it runs a mini reduce on the map side, and then what you actually end up getting here is not ones. You get like 8, 2, 1, right? So the reason why you do word count with ones is because of that. But there are some situations that you're right. You can just have null in the value, and then you just do the length, for example. Yeah. Yeah.
So real quick, can you just talk about the memory requirements? In other words, if I have a terabyte file and I built like a queue today, you set the max of like 2 gig.
Yep.
Imagine sending in 2 gig of data into a particular Python script.
That's a great question. So Hadoop in general, across the board, and it's true with the things that are the Python stuff that are implemented with it, are very memory conscious. So what I mean is that it processes a record and then lets it go, and then cleans it out and goes to the next record. So when I have a 2 gigabyte block size, I'm streaming that data through. I'm not loading that 2 gigabytes in and then processing it. But be scared of memory. There's a couple things you need to be worried about here. So for example, in here, this is streaming through. That's great, right? This is constant memory footprint. Like it's not ballooning in any sort of way, right? Well, actually it is, right? Let's say that you have a file that doesn't have a new line in it, right? If you have like a 2 gigabyte file that has no new line in it, this word re find all is going to run over 2 gigabytes of data, in which case you are going to blow your memory, right? So you have to be careful of that. The other one here, which you run into problems, is this guy. So counts is implemented as a generator for the reason of memory footprints, right? And some behind the scenes is going to be smart enough to use that generator properly. It's not going to cast the list as a list and then add the values, right? It's going to go through one by one and keep a running sum and then output it, which is a very nice way to do sum in a memory perspective. But I mentioned median earlier, right? Median is something that's very hard to do if the list is not sorted, right? So in the example that I have later, or the exercise that you have later with median, you slurp this thing into a list. And if you have a lot of things that had that key, then you're in deep trouble, right? So I'm not saying that you're just going to completely ignore memory situations, but you can ignore memory for the general case. But there are several places when you're dealing with a lot of data that you do have to be worried about memory. The one thing that you have to be scared about with Mrjob is that since Mrjob is running outside of the JVM in a shell, that's delegating to the OS's memory management, right? Inside of a JVM, you're much more safe, I guess, in a sense. If you blow through your memory on a JVM, right, the JVM just crashes and your job crashes and nothing that bad happens. But if this Python script is doing something really nasty, it's running outside of the JVM, right? So you have to be pretty careful. Then you're sharing the cluster with 100 other idiots, and yeah. So if I wanted to like really harden this code, I'd probably before I started doing this, I'd probably measure the length of the line, and like maybe if my reasonable line length is like, let's say, I don't know, 1,000 characters. Before I'm like, this is something weird. What I'll do maybe is I'll just say, if the length of the line is greater than 1,000, I'll throw some sort of warning, and then I'll truncate to 1,000 characters or something, and then keep going, right? Yeah, yeah. So there's something called counters, which we'll actually talk about in one of the exercises. And counters are these things that you can kind of post an increment message to it. So you can count and say like, hey, I saw a line greater than 1,000. And it'll keep a counter so that when the job runs, you can say like, oh, I saw 3 lines that were greater than 1,000. That's weird, right? You can also write warning messages as well, and it'll get logged into a log message thing, and it gets generated alongside with the job. So if you really wanted to log the line, for example, you can write via the logger to this thing. Yeah. All right. Any other questions about this guy? Let's see here. So before we go into the exercise, just because I'd rather just get the slides out of the way. So this is the performance benchmark that I talked about that you guys are going to be scared of. Now, let me caveat this with a little bit. This was written in 2013, And Mrjob in particular has had a lot of development done since 2013. So these numbers may be a little out of date, but still. There's also a particular improvement that was made with Mrjob in terms of how it serialized data in between phases, which was a huge performance bottleneck, which should also make these numbers better. But I just wanted to give you guys order of magnitude. So if you look at this chart, and this chart, if you just Google for like Python MapReduce Cloudera or something like that, you'll get this blog post which describes the different frameworks in detail. So there's other options too. So there's Hadoop and Dumbo were two ones that were Python MapReduce, but I checked their GitHub pages and they haven't had commits in years, which usually for me is a no-go in terms of using it. The two ones that are actually competing quite a bit now, I think, are Mrjob and PyDupe. So PyDupe is another one that basically does the exact same thing as Mrjob. I haven't used PyDupe enough to really tell you guys like which one I think is better. They both seem completely reasonable, and PyDupe has some interesting things that may help it with the performance. So, but I do intend to check it out at one point. But so this is the Java information, and particularly down here is this job runtime that we have, which is took 1,000 seconds for this job to run in Java. Streaming, this underlying streaming thing that I've been talking about that Mrjob is running underneath, you can use that directly. So you can write scripts and then pass it in, and you just need to know how the standard in, standard out scheme works. That was about 50% slower. So it took about 1,500 seconds instead of 1,000 seconds to run it through streaming for the same task. Okay. Now you run to Mrjob, and it ran 7.3 times slower than Java, 7.3 times. So it took 7,000 seconds instead of 1,000 seconds. That's a pretty big difference. Pretty big difference. So what I'm kind of saying is that there's been improvements to Mrjob and fewer improvements to Java, or at least the improvements that have been made to Java get inherited by Mrjob. So if I had to guess, like, I probably wouldn't be surprised if this number was today closer to 3 or 4. So Dumbo actually did some pretty cool things from a performance perspective, which I'm kind of sad about that it ended up not staying around. But that guy was at 3.9, and Hadoop was at 4.2, and PyDupe, which is this other main competitor, they couldn't even get to compile here in 2003. So PyDupe has also had a lot of improvements since then. So they didn't even have numbers there. But so let me kind of talk around this 4x number. Let's assume it's 4x just to be generous. It really depends on what you're trying to do. So let's say that I have this insight that I want to figure out, right? I want to write this MapReduce job and figure out how to solve the problem, right? And this thing takes 1,000 seconds versus, let's say, 4,000 seconds. That one insight is going to take my developer time as well. I'm going to tell you right now that probably compiling is going to take 3,000 seconds, right? So if I'm just like playing around with Hadoop and I'm exploring data, and I'm trying out different ideas, I'm digging through the data, I'm going to take Mrjob with a 4x performance hit every time. Because I'm going to use that time somewhere else when I'm using Java, right? However, when time comes to really run something in production, and this means like running it every 30 minutes or something like that, and performance becomes more of a concern, it may make sense to really kick it over and go re-implement the thing in Java. So me personally, the way I use this is that I'll use like Mrjob for my data exploration, data science-y kind of things. But if I'm writing like production workflows that is going to run over and over again, I'm going to write it in Java, me personally. But me personally, I think me as a person in the type of consulting jobs that I have and the projects I work on, I'm much more in the lane of I'm doing data analysis, not writing production workflows, right? So I guess when you're stepping into a problem, ask yourself the question, how many times is this thing going to run? If it's going to run like 2 or 3 times, because you're going to look at it, look at the results, and go report up to your boss what you found, and that's great. If it's something that it's going to be running for every 30 minutes for perpetuity, you probably want to implement that in Java. Okay. Yeah.
Do you have any sense of whether tooling is being developed in the whole Ruby, Scala, domain?
Yep.
It seems like a lot of the problems
Yeah.
associated with Java,
Yep, absolutely, absolutely. So Scala has gotten a lot of traction in Hadoop. I think Clojure less so, but Scala definitely has. And there's a couple of, so there's kind of two answers. So one is there are some MapReduce frameworks that use Scala, and one is called Scalding, which is pretty cool. So Scalding is really neat. If you're a Scala programmer, you should definitely look into that. It's also higher level than MapReduce as well. So you kind of write these higher, more generalized workflows. So that's neat. And then I think you can write MapReduce jobs in Scala as well, which is neat. And then Spark, which is a separate execution engine from MapReduce, which also has a higher level interface as well, just in general. Scala is kind of like its native language. So I think most Spark programmers I know use Scala. So yeah, they're definitely reasonable solutions to this problem. Yeah, yeah. I think people are starting to realize that too. So yeah, I don't know, maybe Scala takes over and then we don't need to use Python anymore. But yeah.
This includes no actual processor. I mean, your three little functions, the macro, the reduce, so if they did nothing, this is the ratio we would see.
No, I think this is actually doing something. I forget what the use case was. I think it might have just been word count. So the mappers and reducers are actually doing something.
Translates into pretty much nothing. I mean, I don't like.
Yes,
like
yes.
an actual
yeah, like.
numpy to do something
Oh,
serious with the data.
Yeah, yeah.
All of these
No.
ratios would
Yeah,
slide you along closer to
yeah.
Python.
I think so.
It'd be closer to one.
Yes. Well, I think there's a lot of boilerplate in the serialization. So what's included in this number, which is actually what some of these things are kind of saying, is that, so one of the big differences here from a performance perspective is this map output bytes. So if you look at this, so for example, this job wrote out 12 gigabytes out of the map phase, which is that map function. Mrjob ran out, outputted 1.4 times that. And the reason for that is just due to the serialization scheme that Mrjob was using. So if it's outputting more bytes and then reading more bytes into the reducer phase, that's going to take a performance hit. So there's like underlying reasons why, due to the nativeness of it, that's always going to make it slower. But you could make some gains, but I think the actual processing of the data, like whether I'm using NumPy or using something in Java or something like that, it's like kind of a different order of magnitude of the issue we're running into with the number of bytes being written and moving things through the standard in, standard out interface. So like, I mean, you could make maybe some gain. It would definitely go closer to 1, but it would never get you down to like 1 point something just because you're doing smarter processing. Like if you had like a no-op job that basically did nothing, like this number would probably still be close to 3 or 4.
Which strikes me the word count pretty close to nothing, but at the same time.
Yeah, sure, absolutely.
U count's going to be so close to 0 that you're just going to basically.
Well, I mean, actually, tokenizing a word is pretty. When you're dealing with this much data, if you're doing, it was let's see, HDFS bytes read, it was like 22 gigabytes, and you're tokenizing every word with a regular expression engine. That's pretty decent. It's not CPU like I'm doing like facial recognition or something like that, right? But it's still, you're using clock cycles, and also too, the framework is just like churning out a ton of clock cycles too. So. Yeah. All right. So we have 10 minutes. So what I'm going to do real quick is I'm going to run through the VM real quick because I think we have a break in about 5 or so minutes. So what I'm going to do is I'm going to run through the exercise, or I'm going to show you guys around, and then if you are so inclined, you can start working on the exercise when you get back from break, and then I'll give you guys about 10 or 15 minutes to work on the exercise when after break. So I've got the VM started. Oh, this is really tiny. I should have thought about this. That's not going to help either. Yeah. No, that's why. All right, that's better. Okay, so when you open up the terminal, I have some message here. You can go into bash RC and remove it if you want, but to get started with the Mrjob stuff, if you do an ls here, you have some directories in here. You've got the pig directory, the Hadoop directory, the data directory. You don't really need to mess with any of those things if you don't need to. And then the one directory that we're going to be using for this particular exercise is the Mrjob _scripts directory. So in this directory, let me actually make this a little bit bigger. Yeah, I'll make it bigger during break. But if you look at this thing, I have 3 examples, and then I have 1 exercise in here. So if we look at the example, so the seniority versus pay is the one exercise I want you guys to do. But if you look at the average, I know you guys probably can't read this, but if you can bring it up on your VM. So this is a average is the more complicated one, actually. Let me look at so I have word count in here. So maybe you want to look at word count first. And this word count is more complicated than the word count that I used in an example. I actually use like stop words from NLTK, and I do some other things in there that are a little bit more interesting. Then I have average, which gives you the average. What does it do? I wrote this like a month ago. Oh, it does the average salary per job title. So if your job title is this, then it's your average salary, and then it finds the top 10 job titles. So if like I wanted to get paid the most money in the city of Baltimore, working for the city of Baltimore, like what job title do I need to shoot for, right? And then max is finding the top 10 paid people in the city of Baltimore. Okay. I actually learned a whole bunch of stuff about Baltimore in this exercise. The seniority versus pay exercise, the way the exercise works, so I have a bunch of stuff in the comments up top here that tell you like what you need to do. Like it's pretty self-explanatory inside of the script. So open up the script in like gedit or VI or whatever, and then just follow the comments. And then what I did was I wanted in the exercise, I want you guys to only be writing Mrjob stuff, not Python code. So what I have is a bunch of helper functions up at the top of the script that like parse the line, extract the higher date and do the date logic, and also converts the format for the salary, which has a $sign in front of it and the cents in it. I convert that to an int for you. So basically, just use those functions in your MapReduce code, and then really only focus on writing the stuff. And then inside of here, each comment effectively translates to like 1 line of Python that you have to write. Okay, so you basically write the Mrjob, you write your mapper class, your reducer class, and then I kind of step through what you need to do for each of the things, and you use those functions up ahead, okay? And then so one thing you might want to do when you first open the thing is if you start up IPython notebook, so you just type in IPython space notebook, it'll bring up this screen. And then if you, actually, I started in the wrong folder, let me go down. So if you look at the Mrjob Python notebook, I'm not really using Python notebook for any sort of good reason, but here is like some examples of how you would run it. So you basically run the Python script, and then the first command line parameter is the input file. So for example, this one, word count, I have this data folder in the Python guy's home directory that has 2 data sets. I have something called a WC data, which is a list of books that I downloaded from Project Gutenberg, which you can run word count on. And then, so for example, here, this word count is running over all the Shakespeare things, which I think was like 4 or 5. So then when you scroll down a little bit, it shows you the output of the MapReduce job. So, and it shows you kind of like all the, all the words here. Then this one is on the Baltimore data. So this is the output of the average. As you can see, it creates a whole bunch of output here. So the top 10 jobs in Baltimore, the best one is this thing called Executive Level 3. I don't know what that is, but I want to be that. Fire Command Staff 2. Then there's Master, which is, I have my own company, so I can make up my own titles. So I think I'm just going to call myself Master from now on. Or Executive Level 3, I don't know. Police Command Staff 2, Executive Level 2. Battalion Fire Chief Suppress. Yeah. So anyways, so those are kind of like the best job titles to have in the city of Baltimore. And then if you go down a little bit, I run Max. And Max is the highest paid people in Baltimore. And if you go down, and this is gross. So they have in the Baltimore data. If you look at the data, it has annual salary and gross. So annual salary is what the salary is. Gross is what they actually got paid after bonuses and things like that. So the state's attorney got paid the most at $240,000. I'm probably okay with that because he probably got paid better otherwise. Then executive level 3, this guy Ronnie, he made $200,000, or his salary was $200,000, but his gross was only $185,000. Maybe he took a long vacation. I mean, these are like state, like these are. I'm not like. So this guy's an HR human resources executive level 3, and he's getting paid $200,000. Executive level 3 in the police department is getting $193,000. Financial administration is getting $188,000. So this one's interesting. This Michael Swift guy, he has a salary of $187,000, but he only got paid gross $3,500. That guy got screwed. Now there was a couple one in here that was pretty interesting. So there was this guy. So this guy's a police officer, Albert Marcus, and his salary is $73,000, and he got paid gross $173,000. Okay, yeah. I mean, this is public data. You can download this stuff. It was just, I'm not trying to insinuate that something's bad, but it's definitely interesting, right? Because like, even if it is overtime, like that's a lot of overtime. Like, do we want our police officers working 100 hours a week? Oh, with this particular guy? Oh, wow. That's cool that I'm corroborating here. And yeah, so there's a bunch of police department guys that are in like the $60,000 and they're making $165,000. Fire chief too. Actually, the mayor is in here. Stephanie Rawlings Blake. She makes less. She's like number 7 in salary. So these executive level 3s. Yeah. So the salary versus pay exercise. I'm going to release you guys the exercise, but one thing, if you look in, there's a folder called Seniority Solution in the Mrjob scripts. That's the solution to it. So me personally, I don't get too much out of like rewriting the code. I'd like just looking at the solution. So if you want to just skip a step, you're not going to get docked a grade or anything. You can cheat. So the solutions in seniority versus pay, and then you can also write it yourself. But the output of seniority versus pay should look like this. So in one of the functions, I put a -1 if their annual salary is null, just to make it easy. So 0 is like 0 years of seniority, and their median salary was $11,000, and there was 2,800 of them. So I'm also outputting the count. Now, you scroll down a little bit, and this is something that I found pretty interesting. There is somebody with 62 years of seniority in Baltimore, and he makes 55 grand. There's 2 people with 53, so 62 years of seniority. This guy started in 1952. He started before my mom was born, working for Baltimore. So, I feel like he's getting shafted too. 55 grand, I don't know. But I think in general here you'll see kind of like the salaries go up as seniority goes up, and then it almost goes down. So I almost feel like after like 40 years of seniority, if you haven't made it to like 60 some grand, maybe you'll never make it, I guess. So that's what your output should look like. So I think we're gonna do a break now, I think. Yeah, so let's do like a 10-ish minute break. So try to be back by 10:45-ish. Well, so let's go until let's try to regardless of what you guys do for the next 20 minutes, do whatever you want, but I'm going to kind of close off the exercise around 10:55 to 10:55, 11, okay? And also feel free to come up and ask me more personal questions if you'd like. We've got this thing that's running the seniority versus pay exercise that you have. So I'm going to highlight this right now. I'm going to click play. As you see, nothing happens, right? Nothing happens because that code is empty. In the solution one, which is right here, I'm going to click play, and then it's going to run. The couple of things to notice here, so if you didn't run it in Python Notebook, for example, and you wanted to run it on the shell, which is completely reasonable, the reason why I even I'm not even really using IPython Notebook to run Python, I'm running shell commands, so the reason why I put it here is because it just allows me to document the steps. So if you were to run this on the terminal, which is probably something more reasonable, is you're going to do Python space, the name of the Python script, and then the first command line parameter is the Baltimore salaries data, which is in data, salary data, Baltimore salaries.csv. Okay. So when you're done with the exercise, then you can kind of come back down here and press play, and then it should run, or at least it'll tell you like what error messages you had. Let me see, a couple other things to note here. This is just in general one thing I kind of like about. I didn't want to have to go into doing anything with like matplotlib or scikit-learn or anything here for this class, just because I wanted to keep it simple. But one thing I want to point out here is that this Baltimore salaries seniority versus pay, when you see the output, it sorts the years of seniority lexicographically. So you get that weird Windows Explorer issue where you get like 1, then 10, then 11, right? So, and that's pretty common. I mean, you're going to run into that with Hadoop all the time. And you're also going to run into other issues where when you have one reducer, so it's sorted. So the sorting is actually a side effect. So you should never really exploit Hadoop sorting for the fact that it's sorting. The reason why it sorts is because that's how it does the grouping in the magic phase that I keep talking about, is it does the sort. And so it comes out sorted. The issue is that if you have multiple reducers, which in this case we only have one because we're running locally, if I have like 100 reducers, each one of the 100 is sorted inside of the 100, but it's not globally sorted, right? So if you just cat the output, it'll be pretty scattered. So what I want to point out here is that I have this Mrjob thing that's running that's figuring out my seniority versus pay, but I want to view the output in some sort of reasonable way, which is sorting by years of seniority. I'm going to do this pipe sort n at the end here. And this is super subtle, but one thing I'm pointing out is that I could write a MapReduce job that took the output of the reducers and then sorted the records and then outputted the sorted records, and that would be great, right? But we're talking about like, when you think about it, I group by years of seniority, right? So maximum, there's going to be like 50, 60 rows, right? We're not talking about millions of rows here. So running a fully distributed, full-blown MapReduce job that sorts 60, you guys laugh, but I see this done all the time, is not reasonable. So what I'm showing here, again, this is super subtle, is that there's place for MapReduce, right? And there's place for sort-n, right? Okay. Try to do my place so none of you leave here and go do that. All right. And that's how we get this output here. So instead of sort here, something that I do a lot, especially with Mrjob since it writes the standard out like this, is maybe this pipe is like to a Python script that's doing some scikit-learn stuff, or maybe I write out a histogram, which then I'm plotting with matplotlib, right? So you don't want to build your line graph or whatever in your MapReduce job. You want to do that outside of your MapReduce job, unless you're building like a million line graphs, right? But if you're only building one, there's no good place to do that in MapReduce. Do it separately. All right. Oh, yeah. Yes. Yeah, so if your job is outputting a terabyte of data, maybe passing that through sort-n is probably not the right choice. So the thing I usually think about is what's the order of magnitude of the output records I'm going to get, right? So if I'm grouping by years of seniority, that's on the order of 50 or 60. If I'm grouping on like employee ID, right? My company maybe, let's say, has 50,000 employees. You know, if I work for a huge company, that's still no problem, right? Let's say you're grouping on IP addresses. At that point, maybe it depends, right? Like if I'm grouping on IP addresses and it's all within a subnet, you know, maybe not a big deal. If I'm collecting all the data on the internet everywhere, then maybe that's an issue. Now let's say that I'm grouping on pairs of IP addresses. So IP address A talk to IP address B. That's when you get a lot of output keys, and that's probably at a point where you probably have a follow-on MapReduce job. Right. All right, so I'm going to step through the exercise. Feel free to keep working on it, but so the first thing that you're going to do is you're going to define the class. This is probably the easiest part of the whole exercise. Just define the class, and I have this class name, and then I inherit from Mrjob. I have a mapper here, which you probably could have copy and pasted from one of the other exercises or one of the other examples. So I have this underscore here, and then I have a line. So the first thing I do is I'm going to parse the line. This is pretty common. So actually, too, I would say that this is even good practice. So this line is coming in as just a raw text line that's ended with a new line, and it's got the CSV stuff in it. I broke this out into a function that basically takes this line, parses it into a dictionary, and then it makes it much more convenient. This is marginally good practice because other people in your organization probably want to parse that line too, right? And having to rewrite that code every time is kind of a pain. So a lot of times I see once a Hadoop project starts getting momentum, and this is true in Java or in Python, is that they start building like this standard library of custom code for your particular organization. And this typically includes like ways to load data, parse typical data types that you guys have. So maybe I would keep this parse line function around, right? So this outputs this dictionary, which has each key is one of the things is a column. So I need to get the hire date. So I have this function called hire date, which takes in the raw date, which is in the form of month slash day slash a 4-digit year. Okay. So if you look at the parse hire date function, it effectively takes that date timestamp in that form, creates a datetime object, and then subtracts from now to give me the the time delta, which then I extract the years from, which then gives me their years of seniority effectively rounded down. So that's all that's done in that function. So hypothetically, if I wasn't helping you out, right? Imagine that, right? You'd have to write the logic that parsed the line, the CSV line. And this CSV is like not the nice CSV without quotes, right? This is the one with quotes, so you can't just split on comma, okay? This one, then you'd write some date logic to calculate the years of seniority, right? Maybe that's a few lines of code. And then I have to parse their annual salary, which came in as a string and had a $sign in front of it. So if you just try to pass that into int, for example, it's gonna barf on you. So so I've got years and salary, and then I yield years, because if you think about it, years is what I'm grouping on, right? I'm trying to figure out how much pay are people getting by year. So that's what tells me, this is kind of where figuring out MapReduce comes in. This what tells me what the key is, because I'm kind of grouping by. So if you think about, like, if you're writing a SQL query, for those of you that know SQL, when you are doing a group by in SQL, that's what the key is outside of the mapper. Okay. And then salary is the salary that I extracted from here. So so in the reducer, the key is going to be the years of seniority, right? So we'll get like 10, 18, whatever, in any sort of order. And then we have the values, which are going to be the salaries, okay? Now, the first thing that I do here, this is a scary memory thing that you have to be careful of, and then maybe there's better ways of doing this, but I was just being lazy, is that I'm going to convert values to a list, because values is currently a generator. And in order to calculate median, I need to sort that guy. So I convert it to a list, and then I pass it into this median function that I wrote, which then gives me the median. And then, again, if this was code that you were writing, maybe you would have written the median code here on that list. And then I'm also getting the length of the list. And then I'm outputting the key. So the key value aspect out of the reducer is kind of arbitrary, because it's just going out to standard out. So like I could technically construct this entire string in the key or the value. It doesn't really matter. As long as if I'm passing this into something else, maybe that would be meaningful, but in this case it's not. By default, it's going to separate them by a tab. So I have key here, which is going to be the key here, which was the years of seniority, right? And then I'm going to create this tuple over here that's going to have the median and then the length of the list. So when you see the output, and then, well, I run it down here at the bottom, right? So when you look at the IPython notebook output, this was the key out of the reducer, and this was the median, and then this was the count. At some point, this converted into a list from a tuple. I'm not sure who did that, but it wasn't me. All right. Yeah. Oh, yeah, let me show you that. So if you go up to the root, you can select, you scroll down a little bit, and you go down to Mrjob. Sorry, you can't see that, but so there's one issue that you might have ran into. You need to start IPython notebook from your home directory. Don't start it from inside of a directory, because then it'll root at that place. So as soon as you open a terminal, type in IPython notebook, it brings up a thing. Then you scroll down to the bottom, and there should be a mrjob.ipynb. Okay. Are there any questions on this on the seniority exercise? On anything weird that was done? Yeah.
What if the file is in HDFS? Would the second parameter or the first parameter would be
The path in HDFS, yeah.
HDFS dot slash something?
Yeah. All right. Oh, that's a great question. So how do you control the number of map tasks that start up? So map tasks in general is something you don't specify. So the map task that start up is going to be assigned to each block effectively by default. So let's assume the salary data, right? Baltimore salary data is not that big. You know, I could have done that with a Python script. There's no reason to do MapReduce Java over it. But let's assume it was salary data for every city employee in the United States, right? And I had one file for each city in the United States. Maybe it would spin up one task for each file. So MapReduce is kind of arbitrary. For the number of reducers, that is configurable. And you would pass that into the Mrjob configuration when you run it. I mean, you can look up the docs how to do that. But the number of reducers you do specify. And that one, it's a long conversation, so I'm going to kind of deflect a little bit and not spend the time to talk about it. But effectively, for the amount of data you think is going to come out of the mappers, you want to scale your number of reducers accordingly. So if you, for example, if you think that each reducer can handle about 1 gigabyte of data due to memory and performance concerns, and you think that the mapper is going to output 7 gigabytes, you might want to have 7 reducers, for example. Yeah.
Sort of got me thinking about another issue maybe with your file system. Is there a definite need to structure your files in a certain way depending on what kind of analysis you do? So if you want to do something based on time,
Yep.
does your folder structure need to convert time?
Yep, that's a great question. So in RDBMSs, you have this notion of partitioning, right? And if you partition a table by a certain thing, you can say, when you run a query, if you know that the query is only going to be running over a certain portion of that data, it'll only load some of it. So time is probably the most common partition scheme. And yes, most definitely, typically what I do is as data comes in, I will put it into a folder, usually per day for most people. So I have a folder for a day, and any data that came in that day goes into that folder. And the reason why that's useful is that I may have my MapReduce jobs running, and I may want to run over a specific day, or at the end of the day, I want to run over the day's data. Right? It makes it very easy for me to specify the path to that thing. So you can almost do this partitioning scheme thing where you only pass in the directory of data that you may have, right? So other partitioning schemes I've seen are like by source, for example. So if I have 3 different sources that are generating the same data, maybe there are 3 web servers, for example, I may want to keep each of those in their own separate folders. Then I can layer, right? So I can have each of them have their own separate folders and then each have their own day folder, for example. Yeah. So there's all kinds of smart things you can do with how you layer your data in your directories that make your life easier later on. But for like time, so the other thing too is that, so you do have folders, but you can also implement a lot of the stuff in the name of the file as well. So I've put all kinds of crazy stuff in the name of a file, like all kinds of metadata. So I'll put like the line count in the name of the file. I'll put the date it was created. I'll put the source system. I mean, I've had like file names that are 80 characters long just because of all the data that it has in it. I mean, short of like actually making the name of the file a JSON object. Yeah. Yeah. The most sophisticated thing probably I've ever seen is that somebody actually wrote a bash script that you pass in parameters to, like, I want files that were generated by this system between these dates and some other criteria. And the bash script would actually rip through the file names and folders and actually return back a list of files that the MapReduce job should run over. So, yeah. All right. Well, let's take a look at Max. Max is pretty interesting. So, what Max is doing, so this dict thing, which is doing the zip and all this line comprehension stuff, I apologize for the how awesome this line of code is. But effectively, this is parsing the line and then creating a dictionary out of it and passing it through a CSV reader. And so what this thing is going to do, now, here's kind of the interesting thing that it's doing. So it's got salary and then it's got gross. So what salary max is trying to do is it's trying to find the top 10 people that were paid for a certain reason, right? And if you look at this, I'm doing yield salary, and then I'm returning the float of the annual salary and the line itself as the value. So I kind of have to explain the whole thing for it to make sense, so just try to bear with me for a second. The key is salary, which is just a static string, and I'm converting it in, and then I'm adding the annual salary as the first item in a tuple, and then I have the line itself in there as well. And then if gross is there, because sometimes that field is null, I'm going to do the same thing, but I'm going to have the key as gross. So there's two separate keys. There's salary and gross. And then if it's not there, this is that, that warning message thing I mentioned earlier called counters. So I do this increment counter thing where I'm saying this is a warning, and I'm going to give it a message saying missing gross, and I'm going to give it a count of 1. So when the job runs, you'll be able to see like how many things are missing gross, right? Now, if you think about this, I am only ever going to have 2 keys, salary and gross, right, come out of this thing. So what the reducer is going to do is it's going to keep this like top 10 list, and it's going to iterate over the values. And this is like probably the dumbest way you could keep a top 10 list, but I'm just trying to get it done. So I'm going to append to the top 10 list. I'm going to sort it, and then I'm going to truncate the 10, right? So, and then every time I'm kind of resorting this 10 list, I'm embarrassed that I even wrote this piece of code, but. And then at the end of this for loop, after I've iterated through all the values, I'm going to yield the key and the key and the top 10 of those people, right? So this reducer function, though, is going to get called twice, right? Once for gross and once for salary. So I exploited the MapReduce framework to basically do 2 separate analytics at the same time. I'm doing the average over the salary and the average over the gross. I think I could have just had 2 separate MapReduce jobs, right? One that did salary and one that did gross, but whatever. But the other kind of interesting thing here to notice is that using this static key is basically a common methodology for basically grouping everything by everything, right? So like I want to bring all the data down together in one place, which can be bad if you're not careful. So the one other thing to notice here is I do combiner equals reducer down here at the bottom. If you remember, the combiner is the optimizer that runs after the map phase that does a mini reduce. So if you think about what this thing is doing, after the mapper runs, it runs a top 10 out of the mapper output. So if I'm running over 8 blocks, it's going to do the top 10 of each 8, and then only the top 10 make it to the final one. It's almost like a tournament, right? So you got the top 10 of each mapper, and then the reducer is getting the top 10 of the top 10s. And then it calculates top 10 over that, and you can see why that would be a lot more efficient. Right? Yeah? Yeah, so if you have a filtering condition, you definitely want to put that in the mapper if you can, because it'll reduce the amount of data that gets shipped to the reducer. So if you said, like, I want to filter out, like, I wanted to find the, yeah, that's a good one. Like, let's say the police department guys are screwing me up due to all their overtime, right? So I'm going to create an if statement that filters out anybody that has police in their agency name or title, right? I would put that in the mapper, because if I put it in the reducer, those guys will show up in the reducer, and then I have to filter them out later, when I should have just done it earlier, right? But in some cases, it's not possible, right? Sometimes you need to do some computation or something like that, you know, and you have to put that filter later. Yeah. All right.
Quick one question.
Yep.
With the combiner equals reducer, if you didn't do that, what's the default
Oh,
combiner?
so if you don't specify what the combiner is, it doesn't do anything, and it just sends the data kind of verbatim through the MapReduce.
That's solely an optimization
Yes.
to diminish
Yes.
the filing.
Yes. If I comment out that line, the job will have the exact same output. It's just the fact that the reducer logic is the same as the.
Let me ask you another question then, Simon. If you use the combiner to reducer, and you're essentially taking the top 10 from each of the groups, and then ultimately you take the top 10 of
Yep.
the top 10, isn't that a bad?
The top 10 of the top 10 will.
You end up, like if the first group has all of the top values in it,
Yep.
don't you lose
No.
the ones that are?
So if you're looking for top 10 and you do top 10 and all the top 10 values are in one file,
Right.
all of those 10 will get shipped to the reducer, and then they'll beat out all the other of the top 10s. So you're not losing any data. You're still getting the top 10. If I did top 5 then top 10, yeah, then that would be bad. Yeah. So you can't always use a combiner too. So for example, the median case, the median of medians is not the median, right? So median is a good example of something that you can't use a combiner for. Average is a little tricky. So if you decompose the average as the average and the count, right, then you can do a weighted average of the averages. And the weighted average of an average is the average. The average of the averages is not the average, but the weighted average of the averages is. So if you construct your average in the right way, you can use a combiner to do average. Right? Actually, we'll take a look here at average, and that's exactly what I do, I believe. No, I was too lazy. So if we look at this thing, the salary average guy here, this guy is wow, we got to start moving a lot faster. So the salary average guy, this is a multi-stage job. So what he's doing is he's finding the average by job title in this first one, and then I then have a separate top 10 thing that's doing the top 10 of the averages by job title. And then setting up a multi-stage job is a little bit trickier here. Okay. But it's not that bad. Basically, you have to implement these MR steps classes, and you pass it what the mapper and the reducer is. Oh, no, I am doing the combiner. I'm sorry. So I'm just setting it here. Okay. All right. So this is how you do a multi-step job. All right. Yeah. Yes. Yeah. Because when you call it mapper, it's actually overriding mapper, right? Yeah. All right. Are there any questions on Mrjob before I move on? All right. So let's talk about Pig real quick. So again, this is intended as an overview. I'm going to glaze over this real quick. So I'm not really going to spend too much time explaining Pig, but this is what it looks like. So you have like different lines, and each line is like a transformation of data. So this is loading, and then for each is like processing each line of data from here, and doing some tokenization, and then I'm doing a group by, or I'm grouping by the word, and then I'm counting the word. So this is word count in Pig, okay, which is a lot shorter than its Java counterpart, which is like 100-some lines. And it's, I don't know, it's like close to our Mrjob thing, which is kind of cool. The one thing that's really cool about Pig, so Pig has this overarching like data flow language here, but in terms of actually manipulating data, it doesn't have much there, and that's what user-defined functions for. So if I have, if I have a user-defined function for reversing a string, so for example in Pig, there's no built-in way to reverse a string, right? So what I do is I write a Python UDF, which reverses a string, and then I add that, I register it into my Pig script, and then now I can use Python UDFs in Pig. And the way Pig is going to work is it's going to take the script here, and it's going to interpret this into a MapReduce job and then run it as a MapReduce job underneath. So as you can see, there's no map and there's no reduce here. It kind of thinks like, well, how would I implement this as a MapReduce job effectively? And then goes and runs it. So it's very powerful because instead of having to deal with MapReduce, it's a much more, it's a higher level, it's more of a declarative language instead of me specifying exactly what to do every time. Okay, so let's go take a look at the pig stuff. So the things in the pig directory. So this is the pig script that's doing the max thing again. So what this is doing is it's loading the salary data. Actually, the top here, it's registering this UDF file, which I'll be showing you in a second. So you have to tell it where my Python script is. And then I load the data using this load line. And then for each line in this file, I'm going to extract the dollar amount. And I wrote a Python UDF for extracting the dollar amount from the raw line. And then I also add the line. And then I do an order by pay, which is the thing I extracted, descending. And then I do a limit of 15. And when I run this thing, it gives me the output. And the output looks a lot like the max from the other guy. When you look at the UDFs, so this is the extract dollar function that I just used here. I could have other helper functions in here that are useful. I can import libraries. I can do all kinds of things. This is just a Python script. And it will get ran once per task. So if I have 100 map tasks, this script will basically start up 100 times. Then I define this function, and I have to put this, this decorator, this output schema thing, into the script. And what this is telling Pig, which is strongly typed, is my output from this thing is an int or something like that, right? So when I'm saying extract dollar, I'm telling it that this thing I'm going to output an int, okay? And if you don't, then things will go very bad, okay? Because it just assumes that you're telling the truth, and then it serializes the bytes, and then it tries to deserialize your string into an int, and then just very bad things happen, right?
So when you say strongly typed, that's not enforced.
Yeah. Oh, sure. Yeah. It thinks that it's
strong in the sense it's going to shit all over everything.
yes. Yes. So if you tell it that's an int, but you actually return a string, it'll serialize the string to the way it serializes, and then when it tries to deserialize it back into an int from the bytes, then that's when it barfs all over itself. Yeah. Yeah. So if you look at the extract dollar function, it's taking in the line, this raw line, and then I'm doing the thing where I'm like, I'm basically using the parse line function that I had earlier, and I'm stripping and removing the dollar sign, and then I'm converting it to a float because it has a .00 at the end of it, and then I convert it to an int. And then if I get a key error, which means that gross pay wasn't there, I'm returning -1. And if for some reason I'm getting a value error, I forget why that was happening. Oh, I was getting a value error because sometimes it wasn't, what was the issue? It was coming in as a null or something like that. And I put -2 there, and then it ended up going away later. But so you kind of write your data transformation, data extraction, parsing, like the logic in Python, basically. So these things are kind of side-saddled. So I have my Pig script, which is doing the grand data transformation movement stuff. And then my Pig script is the one that's actually digging into the data and extracting values, right? And this is a very powerful combination. And you can also write UDFs in Java and JavaScript and a few other things as well. But obviously, Python is my favorite. There's 2 ways of writing the Python UDFs, which is important to state. There's when you do this register, my Python UDFs using streaming Python as UDFs, and I give it a name. Streaming Python is a lot like Mrjob, where it's going to start the Python process and then funnel data to it through standard in and pull data out of it through standard out. Okay? Now that is bad for a lot of reasons. The other way of doing this is with Jython. So Jython is the Java-based interpreter for Python. And for this case here, everything I did here could have been done in Jython. So you should have used Jython for this. Okay? the one place that you really want to use stream, so I guess first try Jython because that's going to be more performant. The one place where stream Python is going to work better is that Jython can't handle the C stuff that people do in some of the libraries. So like a NumPy arrays, for example, is a big one. So like NumPy arrays behind the scenes are all implemented in all this like magic C stuff that I don't understand. And Jython just can't even begin to handle that just because of the way it works. So you need to use the CPython interpreter. And that's where the streaming Python as UDFs work. So let's say I have a script where I have some stuff intermixed. So I have some stuff that could easily run in Jython. I have some things that could run in CPython. I would just separate those UDF files into two separate ones. I'd have everything that can run in Jython, I'm going to run in Jython. Everything I need to run in streaming, I'm going to run in streaming. Right? It's nice to have both, but realize that Jython just can't handle everything, right? Usually when I start importing libraries is when I need to start using streaming. All right. So yeah, it's pretty much that easy. So when you submit your Pig job, it'll automatically ship the Python script with it and everything, and you're good to go. Are there any questions on this Pig thing?
So streaming Python would write stream.
Oh, it would just be Jython.
Just for Python?
Yeah, but you need to have Jython installed, obviously, and I don't have Jython installed on the VM. Actually, that's the reason why there's some sort of issue with getting Jython installed on CentOS 7 that I was having, and I was just kind of like, it's not that important. So for the intents of the class, I did not install it. And also, too, you'd have to have Jython installed on all your nodes of your cluster as well. All right. So I really highly recommend Pig. So I think I generally write Pig plus Python UDFs more often than I write Mrjob. I think you get better performance out of it. And Pig is a pretty reasonable language, in my opinion. And then I can still do the Python stuff I want to when I need to. I think Mrjob is still going to be better for maybe more unstructured data analysis or things that are with trickier data types. And also, too, sometimes you just want to have the control of writing. Oh, well, here's an example of something that's really bad. I'm using order by here because of convenience, the fact that it has the key. It has it available to me. But if you remember me piping the Mrjob output to sort, this is actually firing up 2 MapReduce jobs to do order by. Even if it's 10 lines, it's still going to fire up 2 separate MapReduce jobs to just process a tiny amount of data. So, so it will add maybe a minute, 2 minutes of runtime. So sometimes getting it done quickly is better than not getting it done at all, I guess. But so Pig sometimes, in terms of some access patterns that it has, you may just be like, you know what, I just need to write the MapReduce job manually, which is a natural thing. Like even if Python wasn't here, there's this fine balance between Pig and Java MapReduce that I've seen people get in very serious arguments about. Yeah. Yeah.
The part where you load your data at line 4, do you often get a use case where you load it from, say, SQL query instead of
Oh, sure.
running it natively on just...
Yeah. That's a great question. So this text loader here, this is something that's really awesome about Python or Pig. This thing, you can write your own custom loader, and when you write your own custom loader, that's Java code. So anything you can do in Java, you can write in a custom loader. So you could, for example, open a JDBC connection on a partition of data and load that into Pig. Absolutely. I think there's things you have to be careful about, but you can do it. Anything you can do in Java, you can do here because it's pluggable, right?
Speaking of the method product generated by
Oh, sure.
output,
Sure.
and locality is something that requires some access.
Yep. I think typically what I would recommend is that if you're trying to slurp data out of a SQL database, there's a tool called Scoop, SQOOP, that makes it easy for you, and then dump that to a file and then run your MapReduce jobs over it. The reason why that's important is because let's say you run your MapReduce job and it ends up like you had a bug in it, and you have to run it again, then you're slurping the data out of the database again. If you just dump the data and then run over it multiple times, it'll make the database guys a lot happier. Yeah. But yeah, it's completely customizable. Also, too, on the output of the thing, it also has a customizable output as well. So you can actually write data directly to a SQL database if you wanted to. But again, it's probably better to write to HDFS and then have some sort of separate process that then loaded the data into the database. Yeah. So from what there hasn't been anybody that's done any sort of real benchmarking, but the guys that implemented the streaming Python thing said that they were getting about like a 2x slowdown from using Jython on just the UDF piece. So I mean, there's the whole job, right? Just that one piece was a little bit slower. In terms of performance versus Pig and Java MapReduce, for simple things, it's very equal. So there's no sort of like necessary overhead. When performance starts getting different is when, for example, that order by in this Pig script, which if I was implementing this manually, I'd have a more clever way of doing that. That's when my MapReduce job would run faster. So there's kind of some situations where Pig will just do something dumb, and you just got to live with it. Yeah. In those cases, you may be talking about like a 2x slowdown, maybe. Yeah. And remember, like a lot of these, when we talk about performance, I'm not saying that performance isn't important in Hadoop, but realize that there's not much difference between 20 minutes and 30 minutes, right? So if you think about it, like after about 2 or 3 minutes of something running, you're already as a person, you're already context switched to something else, right? So like, maybe you went up and got some coffee. Maybe you start working on this other task, right? So, and then not only that, but then when this thing is running in production on your cluster, right? The difference between 20 and 30 minutes, there's no human time involved in that, right? So your results are coming out 10 minutes later. So here's an example. One very common pattern with a batch MapReduce job that runs every day is that they'll kick it off at like midnight, and then they'll get it ready for around 4 a.m., let's say. So this is pretty common with recommendation engines. So they'll kind of calculate all the recommendations for the day that they were going to make, or maybe a marketing campaign or something like that at the beginning of the day. If that batch job takes 4 hours instead of 3 hours, so it's done at 4 a.m. instead of 3 a.m., does that really matter? Yes. So it'll depend on your environment as well. So like the people in Amazon are going to care about this problem a lot more because, yeah, they're spending more CPU resources. People on bare metal, a lot of those clusters are underutilized. So I think it really depends on the environment. You're right. When I'm working on a project that's in AWS, I'm spending a lot more time thinking about how I'm going to get this to be more efficient. Yeah. So I guess what I'm saying is think about if performance is really important to you. If it is, then I'm not saying it shouldn't be. I'm just saying that in some cases, I think people just naturally think that performance is always important. Right. All right. Then you also have the trade-off of was it easier for me to develop? So for example, this order by in the Pig script, if I had to do this trickier, maybe it would have taken me a day, 4 hours maybe to implement that in Java, that tricky thing where instead I got this done in 10 seconds, right? So then you go into that thing is like, is this something I'm going to run only once, or is this something that's going to run every night forever, right? All right. Any other questions on Pig? Yeah.
So does this also work like Mrjob, basically help itself and then just like check?
Yep. So yeah, so Pig is a little bit more native. So the way Pig works is that it has this primordial, I call it primordial MapReduce job. That's effectively like an embedded Pig interpreter. So what happens is that it fires up a native Java MapReduce job, and it takes the Pig script, and then it's almost like a SQL system. So it takes this and creates a query plan, and then, but the query plan is in MapReduce jobs, right? And then it'll go fire the MapReduce jobs, and it knows what it needs to be doing from the script perspective, but it's still underneath a Java MapReduce job. So there's no sort of weird serialization, deserialization, or standard in, standard out stuff that's going on. So from a performance perspective, it's basically as good as MapReduce. Yeah. The difference between Pig and raw Java Hadoop performance is almost like the analogy of Python versus C, right? There's more stuff. There's a interpretation overhead that's going on, but in general, like disk I/O is almost like is the major portion of job runtime, and like that kind of eclipses the differences between interpretation. Yeah. All right. Any other questions about Pig? All right. One book that I'll recommend to you guys if you want to look at Pig and Python is Agile Data Science by this guy Russ Journey. It's through O'Reilly. It's not necessarily the most useful book that I've ever read, but it's definitely like one of the most fun that I've ever read. What I mean by that, not useful in the sense, but like, for example, like the Python cookbook or the cookbook versions of the O'Reilly books are like probably the most useful books, right? Like because I can kind of look at something and immediately get some code, right? It's almost like that. This is almost like trying to teach you like a Zen state of mind or something like that in terms of how to be doing data science. And he spends a lot of time using Pig and Python. So if you kind of think that this workflow might be for you, you should probably go read that book. All right. Any other questions about Pig? It'll be funny if Russ actually ever sees me say that in a video that I talk about. So the last thing I wanted to talk to you guys about, or the last thing I wanted to show you actually code for, was this thing called Snakebite. And Snakebite's kind of fringe, but actually let me open up the slides real quick. So Snakebite is a pure Python client. So one of the issues is that Python doesn't really have a native way to communicate with HDFS. So Mrjob and Pig I showed you is communicating with MapReduce in the execution engine. Snakebite provides you the APIs into HDFS. So if I want to write a Python application that's writing a file, you're not going to be able to do that in Snakebite, and I'm going to show you that in a second. But pretty much everything else, such as reading files, moving files, renaming files, is all things you can do in Snakebite. And there's two ways of using it. It actually has a command line interface and a Python module. And the one thing that's really interesting about Snakebite is that it's actually better than Java in this one case. So the way that it's better in Java is, so when you're interacting with HDFS through the command line with the Hadoop command, it spins up a JVM every time you run a command. So if I do hadoopfs ls, which does an ls, it spins up a JVM, installs all the Hadoop stuff, runs your ls command, then tears it down. So hadoopfs ls will take you about like a second to 2 seconds. I think eventually you just get used to the lag and you just stop noticing it. It's like I don't know, some sort of, what's that syndrome that you start synthesizing with your captors? Yes, I think a lot of, like, I have it. I think you start synthesizing with Hadoop because it's like your captor, right? There's all these things that Hadoop doesn't let you do. And you just start sympathizing with it, right? Like you know, my argument about performance, that's just me trying to like justify, I'm trying to synthesize with it. But anyways, the Hadoop command is kind of slow. Snakebite, since it's Python, will spin up a lot faster. So you can do like ls's and move the files and things a lot faster. And that was the reason why it was built. The reason why it was built was that the guys at Spotify were building these workflows where they had these Python scripts that were like moving files and renaming files as they came in. And they ran into an issue where, because the Python scripts were just wrapping hadoopfs ls commands, it was running into this issue where like they actually ran, it was like spending so much time running JVMs that they were like, there's got to be a better way. So they implemented this thing called Snakebite, which uses the native HDFS protocol to communicate with it with no Java involved. It's doing native communication. The issue is that writing in Hadoop is really, really complicated. Like the code behind writing in Hadoop is actually quite complex because it has to deal with replication, communicating with the name node, and then the protocol for writing down and syncing and all kinds of stuff. It's really weird. So they just haven't gotten to that yet, but they can pretty much do everything else. So it can read, they can do all the metadata operations, which are like moving files and things like that. So if you want to take a look at Snakebite, so in the command line utility, you basically just use Snakebite instead of the Hadoop command. And here's an example, for example, of this is kind of going back to that one question about what kind of tricky things can I do with my data layout. So, for example, this is something I've done in Snakebite before, which is I have ls this directory that has new files coming in. So when my applications are writing to this new directory, I'll have a for loop that goes over the things in that folder and then moves them to the date folders that they need to be in, right? And I'll have this process. I'll install this in cron, right? And I'll let it run every 2 minutes or so. And then you can even get fault tolerance by running this script in like maybe 2 places, making sure that they're not running at the same time. So Snakebite's really good at something like that. And also has the library. So the one thing you might be able to do is, for example, let's say you have your Mrjob thing, as you remember, is a Python script, right? So one thing you might want to do in that Python script is you could actually have follow-on computation that's done on the output file. Let's say you remember that sort that Dash and I did at the end of that Mrjob thing. Let's say I wanted to do something more complicated, like build a histogram in matplotlib. I could run my Mrjob thing and then load the output using Snakebite, and then building my histogram on that, right? So you can build more complicated workflows by interacting with these things. So in the IPython notebook, I've got some stuff going on with Snakebite here. I had to exercise with it, but unfortunately we don't have enough time. But the general way that the module will work is that you run Snakebite, you import Snakebite client, and then you have to specify where HDFS is. So HDFS and Hadoop need to be started on the VM if you want to do it. You have localhost in this case, port 9000 is the default port for namenode. And then it's got all these different functions. So here's the list of all the functions that it has. It has cat, which will pull the data out of a file and bring it in. You can change the ownership. You can copy the file local. You can, let me see, you can do all kinds of things. So you can rename the file. You can remove directories. You can add directories. You can delete files, right? Like you could implement, let's say, an age-off process in Snakebite. Right? So here's, for example, the output of ls. So I'm doing client.ls, and then I'm passing it the path, and it gives me this dictionary, which includes the group, the permissions, the file type, whether it's a directory or a file, modification time, and then the actual path. So you can kind of see here where you can write these kind of data orchestration things in Snakebite. Here's an example that I take the top words from the word count. So I had that word count job that I ran earlier, right? But the output came out and the words were not in sorted order, right? So here I have this, I load that file and then I create this sorted output, and I'm basically, I'm not sorting here. I'm pulling out all the words that had a count of over 200, okay? And all the words that were out of over 200 in Shakespeare, the Shakespeare data was this thing. So I think this was Shakespeare. Maybe this was Pride and Prejudice, I forget. I don't know, maybe some literary genius here can remember. But so what I was looking for here were like the names. So we had Jane and Elizabeth, Darcy, Bingley. Does anybody know what book I'm talking about? Is this Pride and Prejudice? Okay. And then Bennett. And also, too, I removed a bunch of stop words from here. So that's why the, for example, is not in here. So as you can see, this is just some Python script that I'm using Snakebite as a convenience to pulling the data directly out of HDFS instead of having some sort of intermediary bash process that's pulling the data down, perhaps. Yep. So Snakebite is just the Python module for reading data out of HDFS. So there's no other way to do that. The way I did it before Snakebite was I would use popen to call the Hadoop FSLS command, right? Because then, it's just complicated, right? Then I have to parse, ls output and things like that. So this is definitely a lot easier to use than that. The other option, which is kind of before this, was let's say that I wanted to post-process this word count output. I might have, like, for example, a bash process that does a HDFS get, which gets the file down and then runs the Python script on it. But now I'm keeping the data in this like intermediary local disk place, right? Which is dangerous for disk storage reasons, right? Yeah. So in general, if you want to interact with HDFS, you should probably look at Snakebite. The one major limitation, again, is you can't write data with Snakebite, right? So that's something that I might wrap with popen, for example, if I really needed to. All right, are there any questions on Snakebite? Oh, that is a great point. So HDFS is not a real file system. So you can't edit files. It has some other semantics that aren't supported, like that require it to be a regular file system.
That's why Snakebite.
Yes, yeah. So most people, when they're interacting with HDFS, are either using the Hadoop commands, like Hadoop FS ls, Hadoop FS put, to interact with it, or they're using the Java APIs, or let's say Snakebite. You can't mount HDFS as like a regular file system that looks like NFS. So now there have been things around this. So one is people have implemented like a fuse wrapper on top of HDFS, which I haven't been super happy with. Like I've just gotten used to the Hadoop commands at this point. A proprietary version of Hadoop called MapR implements NFS mountability, but you're gonna have to pay for that. And then also, too, some people are thinking of ways that maybe they can make this problem better, I guess. But for the most part, like most people today are just interacting with it with the command line utilities or the APIs. Yeah. All right, I'm gonna blast through this stuff in the next. Do we end at 12 or 12:20? Okay. All right, we've got plenty of time. So the one thing I want to talk about. Now, this one's going to be a little bit disappointing, but HBase is so HBase is this distributed database that runs on top of HDFS, and the reason why HBase exists is because we've been talking about a lot of the limitations of HDFS in terms of the can't edit files, for example. So let's say I did want to keep some sort of record of something and I want to update values, right? Or the other issue with HDFS is it's all file-based, right? So if I have like 10 records that I want to write into HDFS, I have to write like 10 records into a file, which is really not good because I want to have larger files. So what HBase gives you is more record-based access into your Hadoop system. And HBase also was based on a Google paper that was published without source code called Bigtable. And Bigtable is actually available through their Google App Engine and all that good stuff. But what Bigtable is it basically described the same thing but over their GFS. And HBase is this implementation of Bigtable that runs on HDFS. And behind the scenes, what it's going to do is you're going to write these records, and it has these in-memory buffers that fill up. And then when they reach a certain point, they get flushed out to a longer file in HDFS. Then over time, you get these lots of these little files, and then they get merged into larger files, which is called compactions. So effectively, what it's doing is it's providing you this key value store on top of Hadoop, but it's almost compensating for all the bad things about HDFS behind the scenes without you having to know about it, right? And that's basically what HBase does. So if you wanted to like host an application that needed to read and write records relatively quickly, HBase could kind of solve that for you, right? So the bad news is that pretty much Java is the only way to interact with this thing today. And let me say too, like HBase is being used a lot. So I think a lot of people are using HBase. And really, unfortunately, one of the only ways of interacting with HBase is through Java. And one of the reasons for this is that the client itself, the HBase client, is incredibly complex in terms of the way that it works. So, and this is true with Hadoop in general and in HBase, but in these systems, is generally going to prefer talking to the system, the guy that has the data directly. So in HDFS, when I want to look up a file and I want to read a file, I ask the master, hey master, where is this file? The master then says, these are the 3 locations in which this file exists. I then go look at one of those locations and start pulling the data back directly from that location. So the client, there's no some sort of like magical RESTful API that like is letting me access HDFS. There's these multiple steps involved here, okay? Now HBase brings it to be even more complicated, where now I have this record-based key value thing, right? So not only, now I have to look up the table and say, hey, I'm looking for this key, which region is this in? Okay, then I go to the region, and then I have to communicate with the thing with Thrift and pass all kinds of protocol parameters down in order to get this thing down. And so it's pretty complicated. So like, it's not as easy as just saying like, oh, it's Thrift, I can just throw some Thrift at it in Python and it'll magically work, right? It's not the case. And the issue is that these projects are moving so fast. The other issue too is that I think from a community perspective, internally with HBase, for example, the communication protocols between the client, the HBase client, and the HBase system is not public. So it's private to the HBase project. So what that means is that it's not expected that people are writing to this public API, protocol thing in HBase. So they have every right to change the internal communication protocol between clients and HBase at any time. So if I write this Python client, they could update something and it would just not work anymore. So I think that's one. There's lots of reasons why this is hard, but at the end of the day, there's this thing, the savior, I guess, in a lot of senses, called the HBase Thrift Gateway. And effectively what this thing does is it does provide that unified API that doesn't require all this hopping around. But the problem is it's a gateway, and everything funnels through that gateway now. So it's not distributed in a lot of senses. So if I'm hitting the gateway, that can easily become my bottleneck. Okay. So I don't know, it is what it is. If you're just doing small inserts and gets, then it's fine. But if you're dealing with lots of data, it might be problematic. There's 2 projects here on GitHub called Starbase and HappyBase. I've used Starbase before, but I haven't used it in a while. Both of them had the last commit about 6 months ago. So these are not by any means like projects that are alive and well, right? So if you have any sort of problems or something like that, maybe the guy will respond, right? I don't know. But so this is really frustrating to me because, I mean, just writing a Java program to access a key value store, like outside of Hadoop, like I'm a big Redis user, for example, and I use the Python libraries for Redis. I mean, I could not imagine how I could make that easier, right? I have a Python script, I do my gets and sets in Redis, it works great. When I compare that to writing to HBase with a Java program, it's just like it's like 2 orders of magnitude more of a pain in the ass. So there was one guy, so I gave this talk, not the tutorial piece, at my local meetup group as kind of a dry run. And there was this guy that kept hammering me about it. It's like, why doesn't this work? And I kind of like just said, why don't you take your frustration and go try to figure out how to convince somebody to actually work on these things, right? And it's something that I hope that somebody picks up eventually. I personally don't have the time for it. I'm sure a lot of these people don't either, which is the problem. So anyways, are there any questions on HBase and Python? So I guess what I'm telling you here is that if you want to do HBase plus Python, you're probably screwed. All right, any questions? All right, so Spark, I wanted to spend a little bit of time talking about Spark. So Spark, I think, is maybe like right at the top of the hype curve. So Hadoop has a new hype thing every year. So every year there's new hype, okay? So first, the hype was just Hadoop, right? So, and you can look at the, I'm actually going to do, one day when I find time, I'm going to analyze the talks given at Hadoop conferences and try to pull out topics. Because I've gone to basically every major Hadoop conference for the past 6 years. And I remember 5 years ago, it was like Hadoop was hype. Like just Hadoop was hype, right? And then the year after that, it was HBase. People were like, wow, HBase is like, the savior, right? But then they were like, realized, well, HBase is really good at this problem, and then, Hadoop's still good at these problems, right? Then the year after that, they were like, streaming. So then, like, Storm came out, and they were like, oh man, streaming is the savior, right? And it was like, well, streaming is good, and then there's this thing called Lambda architecture you guys should probably look into. And so they were like, well, these things are all complementary with each other, right? Then so that was year 3. Year 4 was SQL on Hadoop. So Impala came out from Cloudera. Hortonworks was making improvements to Hive. Pivotal made Hawk. And then there were some other startups like Hadapt, and there's Splice Machine. So there's all these SQL on Hadoop things that came out. That was the hype of that year. And then this year it's Spark. So I don't know. So take that as what it will. Like, I guess the hype's not bad because all those things are still useful, right? Like all those things I just mentioned are still being used. But I think you're starting to see where I think it started out saying Spark is going to be replacing everything, and now people are starting to reel back and be like, well, Spark's really good at this and maybe not this. And so, we'll see. I think in a year or so we'll have a better idea of what it's good at. But Spark is really cool for a lot of reasons. So the first thing that I really like about Spark, maybe it's not well documented, is Spark came out of this Berkeley lab that did a bunch of other really cool stuff, that built Mesos, which is a distributed thing, and they've done a bunch of other cool stuff. The one thing I like about Spark, because especially when you compare it to the SQL on Hadoop hype phase, was Spark was just like this organic, like it felt actual open source, right? It's not some sort of Red Hat like vendor that's like doing work through what looks like open source. Like they kind of did open source the right way, in my opinion. So that's kind of one good thing. The big difference between Spark and MapReduce is that Spark, in general, I think the general takeaway is that Spark is a lot smarter about how it uses memory versus how MapReduce is using disk. So when MapReduce runs, MapReduce may check into disk 5 to 7 times every MapReduce job. So it loads data out of HDFS, runs it through the mapper, it writes its output out of the mapper into disk. The combiner then runs, pulls that data off disks, and then writes it back to disk. And it's partitioning, it's writing to disk. And then the reducers pull the data over, and lo and behold, write it to disk. And then it sorts the data in order to do grouping, writes it to disk, and then runs the reducer code, then writes it to disk, right? So as you can see there, like writing to disk is, well, it's expensive too, right? So what the Spark guys kind of figured out was, hey, there's some interesting things we can do in memory. Now, the downside of doing everything in memory is volatile, right? So in a distributed computing system, let's say I have 1,000 nodes, and I'm storing my data set in memory across these 1,000 nodes. If one of my nodes dies and I lose the memory that's in there, I basically have to restart the job, okay? And that's really bad because in 1,000 nodes, things are going to fail, okay? So what the Spark guys did was they implemented this thing called an RDD, which is a resilient distributed data set. And what it does is it keeps the data in memory, but it's smart enough to figure out how to rebuild data that then gets destroyed. So if a node goes down and the slice of the data set is now gone, it can kind of figure out how to reconstitute that data somewhere else. So there was a lot of engineering effort in terms of figuring out, like, how are we going to have the trade-offs of the bad things that go in memory and how we're going to deal with them, but still be able to keep them in memory. So what Spark is really good at is good at iterative processing. So if I have like the MapReduce job I showed you guys, which did the average salary and then did the top 10, that had 2 MapReduce jobs. I mean, you're thinking about that. You're checking into disk like, 14 times, 12 times. Spark will do the average in memory, and then it'll run the top 10 in memory. It's not doing very much to disk. So when you have these multi-stage jobs, you can get some very significant performance improvements in Spark over MapReduce. And then also, too, it's been kind of shown, too, that Spark is, even when you're pulling everything on disk, still sometimes is slightly faster than MapReduce. So anyways, Spark, I think, almost the majority of cases it might be better than MapReduce, but I think the word is still out. One of the problems, too, is that Spark is still also relatively new. MapReduce is very stable. So I think I personally have run into issues with Spark. This is my personal opinion. I've run into issues with Spark that I don't feel like I run into with open source technology that's been around for 12 years. Right? So take that as what you will. So anyways, one thing I really like about Spark, too, so Spark's native language is Scala, and you can also write Java into it very easily. But they also do a very good job of keeping up a native Python API into it. The Python API, unfortunately, in Spark is always like maybe one version behind or maybe missing a functionality here or there. But I personally have never ran into like a feature that I really, really wanted to use in PySpark that ended up not being there. And so effectively, the way you program this thing is you write these Python scripts with the Spark APIs that are dealing with the RDDs and other aspects of Spark, and then it deploys it on Spark. So let's take a look at word count in Spark. And Spark is also very different than MapReduce, so it doesn't have mappers and reducers. Basically, the way it works is that, so I implement this PySpark thing, and then I create this Spark context, which tells it kind of like, this is my job, my interface into my job. And then from there, there's all these like fluid functions that you can call. So for example, sc.text file, I pass it into lines. That loads a file as text, which means that I'm expecting it to have like new lines in it. And then this is how I'm doing the count. So I'm doing flat map. So lines, I'm taking the lines. I'm doing dot flat map, and then lambda x that's split on space. So why am I splitting on space? Because I'm tokenizing words, right? So this lambda expression is a function. I mean, it doesn't necessarily need to be a lambda expression, right? It could just be a function outside. But what this is doing is it's saying for every line of text in lines, split on space. Okay? And then do a dot map. So not map in the MapReduce sense, map in the functional programming sense. Lambda x, comma 1. Okay? What the hell? There's actually a big chunk of the slide missing. I don't know what. I'm sure like my 2-year-old was like, he does drive-bys on my laptop and like slams his hand on it. And I find that sometimes like he deletes like large chunks of my, like I'll run programs and they won't work anymore, and then I'll realize that there's just this like thing that was obviously deleted. So I'm going to blame him for this. But so you have map lambda x, and then here is x comma 1. You should be reminded of the x comma 1, right? This is how we're going to set up word count, right? We saw word x1, and then what should have been here was a sum on the ones. Or we're going to do actually a dot group by on x on this thing, and then we're going to do a count on a sum on the ones. So as you can see, this is very different than MapReduce, right? And we're doing this fluid. So these Spark programs end up being like the complicated ones end up being like this long series of like dot operation, dot operation, dot operation. And then Spark takes this kind of plan here and then goes and executes this thing in memory. So if you think about it, like if I were to implement the average top 10 thing, I would implement the thing in Spark where I would do the parsing, I would do the group by, I would calculate the average, and then I would do the top 10s of the averages. In the RDDs, it's going to stay in memory, right? And then instead of flipping over to new MapReduce jobs. So if you haven't signed up for a tutorial tomorrow morning, I would really recommend that you check it out if you thought this was interesting, because it is going to be important to if you want to do Hadoop stuff in the near future. So I just copy and pasted what the tutorial description was. It's tomorrow morning. Let me see. All right, that's it. That's all I have for slides. So we have 10 minutes left. Does anybody have any questions? Yeah.
Can you talk a little bit about when Hadoop first started, it was big that it could run on commodity.
Oh, sure.
Can you expand on that a little bit?
Yep. So originally in the GFS paper and the MapReduce paper, one of the things the Google guys said was that this is really important to us because it runs on commodity hardware, is what they said. And what they meant was that the software that they built, this distributed technology, I'm not a fan of the term commodity hardware. What I've been using is non-proprietary lately. And what I mean by that is that it will run on generic hardware. So if you have generic x86, pretty simple operating system, no special hardware. This is the same kind of hardware that you're running your web servers on, for example. And the big deal for that is that it allows the organization to separate hardware from the software platform. Because if you think about, when I remember when Hadoop was first coming out, everybody's freaking out that this thing was going to kill Oracle, right? And if you looked at the difference, like when I was going to Oracle, I mean, I could install Oracle on my own hardware, but a lot of the guys that I was working with had like Oracle appliances or had like standard Oracle solutions, and they required some sort of like fancy storage with like fiber channel. It was like a hardware-based solution. Like I couldn't go like play World of Warcraft on like my Oracle server, right? So what the commodities, the idea of the commodity hardware was that, hey, we're going to kind of compromise here, and we're going to get more generic hardware, but we're going to buy a lot more of it, right? So Google is going to say, well, we'll buy 1,000 of these things instead of maybe buying like 10 of the fancy ones. But the idea is that we're going to be able to scale that thing a lot larger, right? So typical Hadoop nodes now are not, the reason why I don't like commodity because it comes across as cheap. Typical Hadoop nodes are not cheap, right? Like the pretty standard Hadoop node configuration these days is like 2 processors, so like a 2U box with 2 processors, maybe 8 cores each now, 64 gigs of RAM. This is something I'm seeing a lot. I mean, I've seen some with like 300 gigs of RAM if they have heavy HBase workloads. A 10 gigabit backplane, a whole ton of cooling. So like individual Hadoop nodes can really be expensive when you're, and also they also have like 12 disks per box, right? But I'm not using like anything proprietary from a networking perspective or a hardware perspective. Like I can get the same thing from Dell or HP. Yeah.
Yeah, I think that I've not seen any of Google's stuff, but they would never touch hardware the way you just described.
Yeah.
That's ridiculously expensive.
Yep.
They use motherboards and they're using commodity hardware.
Yep. Yep.
It is cheap.
Yeah. Actually, the Hadoop guys.
As it can be to do the job they need.
Yep. Actually, the Hadoop guys are, I think, a little bit different in the sense that they are using commodity in both the commodity non-proprietary sense and also the cheap sense. I think people that are a lot smaller than them, I think, are better suited to having hardware that, I think one of the issues that, it's kind of funny when physical realities come into play. One of the major bottlenecks that a lot of my customers have is actually like floor space in their data centers, where, I could really spread it out by you can really spread it out by having a bunch of crappy hardware, but I think most customers are going to prefer having a more compact, and it's also too, from a performance perspective, it's more cost effective as well to have, let's say, let's just imagine I had a 2 CPU box with 64 gigs of RAM and 12 disks. That's cheaper than 2 boxes with 6 hard drives each and 1 CPU each and 16. It doesn't scale linearly. The hardware doesn't. So when you pack more into one box, it ends up being cheaper, actually.
I mean, they buy their own motherboards.
Yeah, right. Which, I mean,
Google doesn't do anything
yes.
the way that.
Google is not like anybody else, yeah. I think,
That's why their definition of commodity hardware matched what we think of it.
Yes.
Nobody else's does.
yes. Yeah. Most people are running Hadoop on just standard.
Yeah, Dell 2U
Yep.
or 1U.
Yep. Any other questions about Hadoop? Yeah.
You mentioned that you work on Oracle, right? I mean, can you explain some successful use cases where we're using Hadoop versus Oracle? What kind of projects were those?
Sure. So so Hadoop versus Oracle. So I think some of the first Hadoop projects I did were replacing Oracle systems, and I think the mentality has changed in 2015 versus 2010. But back then, I think one of the things that people were looking at was Oracle workloads were getting too heavy, and they needed to go pay Oracle more money to upgrade their systems, and they were kind of nervous about that. So for example, the first project I ever did took an existing Oracle system that was doing like OLAP style analytics, and it was doing nightly rollups on data for performance reasons. And daily rollups they started getting serious about Hadoop when daily rollups started taking 25 hours. So this system, a daily rollup would take about 25 hours. And so that's bad, obviously. So they started skipping Saturdays, for example. So like they wouldn't be able to analyze data on Saturdays, which was okay because it was less busy. But so what we did was we took the rollup logic and implemented it in Hadoop MapReduce. And then we would take the output and then send it to the Oracle database, and then they would like load it up into the Oracle database. And then they didn't have to do rollups anymore. So obviously that had, not only did they not have to do rollups anymore, but they also were able to do more stuff because now the cycles, CPU cycles and stuff on the boxes were freed up. So users started seeing the system run faster and everything like that. So I think that actually foreshadowed, I think, a very common problem or pattern these days. Actually, is that if you're using Hadoop for its batch processing, like MapReduce, it's a good behind the scenes kind of like workhorse, but it doesn't really replace necessarily like a SQL database in some cases. Like being able to implement an application that's cooked into JDBC or something like that into a SQL database, or building like an object model or something like that. I mean, those are all still really useful things. So sometimes you can use Hadoop to augment. I think what people found is that replacing sometimes is different from augmenting, and I think augmenting is the much better use case for Oracle. I think Oracle also figured that out as well too, because now they have like this big data appliance where you can have Oracle sitting next to Cloud Era Hadoop and stuff. So I think that's in general, but I think you can also get away with not having to have Oracle with some of the SQL and Hadoop solutions as well, but it's still not as good. So yeah.
So you touched on HBase. I'm just wondering, is there anything for Accumulo?
Yeah. So yeah. By the way, I'm actually a huge Accumulo user.
Oh, really?
Yeah. Yeah. So Accumulo is a alternative version of the same concept as HBase. So it's a key value store built on Hadoop. It's not HBase at all. It was built separately, but it's both are based off of the HBase, the big table paper. And Accumulo's usage is a little bit more niche, but there is this PyAccumulo library on GitHub that the last time I used it, it took a while to get it to work. But once I did, it did work. The thing is that it does use a proxy technique like HBase does, where it uses the Accumulo proxy. So I guess for smaller things like just being more agile, it's good. But if you ever needed to like start writing large amounts of data into it or reading large amounts of data to it, then it might be not well suited. Yep, it's the same problem, and they're actually architected in very similar ways with Thrift and stuff. So yeah. Any other questions? All right, so just to kind of wrap up, I think we ended up having a lot of good questions. I ended up answering a lot of these good questions. So I was kind of hoping that you guys would have had a little bit more time to do some hands-on stuff. But if we had the time, so in case you think you want to go back and spend a little bit more time with this stuff, the thing I was going to have you guys do with Snakebite, if you wanted to take a look at that, was basically doing that thing I just showed you in the slides, which was doing an ls on a directory and then renaming the files based on, and basically moving all the files from one directory into another directory and doing a little bit of transformation on that. So that's in the IPython notebook. You can look at that there. The other thing you guys can look at is, I wasn't going to have you guys do a pig exercise, but I think it wouldn't be terribly hard maybe to look at the salary data and try to modify the pig script a little bit to maybe do some things other than max. I think that would be kind of a fun exercise. And then the Mrjob thing, one thing that I wanted to do, but I knew I wouldn't have time, but maybe I implore you guys to do, is like try to integrate like Mrjob with maybe your favorite Python library. Like if you're a big pandas user or you're a I don't know, big NLTK user, try to like implement one of your current workloads that you are familiar with in Mrjob, and I don't know, post it to GitHub and let me know how it goes. Yeah. Oh yeah. Let me show you guys that. So in this VM, so I have HDFS and all that stuff set up for the Snakebite exercise. So when you guys do that, both Mrjob and Pig can run locally. The big difference is that when you're running locally, it's performance heavy is not as bad, or it's not as performance heavy, so it runs better in the VM. When you actually run Pig, for example, against HDFS and MapReduce in the VM, like as an actual Hadoop service, it'll take a long time. Like I think it took about 20 minutes, I think. Yeah, it has a lot to do with the resources on the VM, like the memory and things. But if you have a better laptop than mine, it'll run a lot faster. So the things to point out here is in this Python home directory, I have the Hadoop stuff is installed here and the Pig stuff is installed here. I have two convenience scripts here. One that I wrote called start everything is one of them, which is a shell script that you will run that starts DFS, and then starts yarn. So DFS is HDFS, and starts yarn. Yarn is this resource manager that one of the things it does is runs MapReduce. And then it also starts this thing called the history server, which wasn't starting but was needed by one of the services I had running. And then there's also a flip script called stop everything as well. I would recommend running stop everything instead of just like shutting down the system cold. Doesn't really matter. Like I've never had a problem with it, but I still like to shut down things safely. So, so start everything, stop everything. So if you just run the shell script, it'll start everything up, and then you can do all the Hadoop commands and everything. And the data is already loaded in there as well. All the data sets that I had in those folders. Yeah. Some general comments on like trying Hadoop more. Obviously, my VM is a good starting point, but the vendors are good places to go to. So Cloudera and Hortonworks in particular. If you wanted to try more Hadoop stuff, downloading their like pre-built VMs are pretty good because they have a lot of stuff pre-installed in those things. It's a good place to start. And I mean, like at this point, Hadoop is very actively used. So Google search is pretty good at finding answers to Hadoop-related things. It was very different back in 2010 when I first got started. But today, like, probably you can answer 75% of the questions on already existing Stack Overflow questions, and then the other 25%, maybe you need to like actually look at Hadoop documentation. The one thing you have to be careful about, I don't know, maybe one day I'll write an email to Google, but I don't even know how you do that. They're really bad. I'm sure you guys have noticed this. They're really bad at catching up on like versions in open source projects with documentation. So like when you Google for like Apache Pig documentation, for example, it'll give you like 3 or 4 versions behind. I don't know how it decides that that's the thing that's going to be the top hit. But when you're Googling for Hadoop documentation, make sure you add the version number. So for example, I have 2.6 in this. So when you're saying, oh, Hadoop, how do I do ls or whatever, do Hadoop 2.6 ls or something like that. Not that these things change very often, but you could get burned at some point. Yeah. Yeah. I'm sure they know. Yeah. All right. Any other questions? So the best way to contact me is via email, this dminer@minerkosh.com. If you have any questions or comments or feedback or anything, please let me know. And it was a pleasure having. Seriously, like great questions today. I had a lot of fun answering them. The problem with this tutorial is like I try to keep it overview, but you guys are too smart. You start asking questions that are like things that I was trying to gloss over. But so yeah, feel free to email me, and then I'll be happy to follow up with any sort of questions or advice that you guys might have. So appreciate your time.